Let your breathing become slow, soft, and effortless tonight. Imagine a quiet window, glowing faintly beneath the winter sky. Outside, snow is falling through the darkness without hurry. Each flake drifts along its own gentle path toward the earth. You do not need to follow every thought that appears. Let each thought pass like snow settling beyond the glass. The room around you feels warm, still, and completely safe. Your shoulders can soften, and your hands can rest comfortably. With every breath, the winter night seems quieter and farther away. For now, there is only warmth, darkness, and falling snow. Snow begins high above us, inside cold and peaceful clouds. These clouds contain tiny droplets, dust particles, and invisible currents of air. When the temperature becomes cold enough, water gathers around a microscopic particle. A small crystal begins forming, delicate and almost perfectly clear. The first shape is usually a simple hexagon with 6 even sides. This 6-sided pattern comes from the quiet arrangement of frozen water molecules. Each molecule connects to others at angles that naturally create hexagonal forms. From this tiny beginning, a snow crystal slowly grows through the cloud. Water vapor joins its edges, building new branches and delicate frozen patterns. The crystal changes as it passes through different layers of temperature and moisture. Some layers encourage long needles, while others create plates or feathery arms. A single snowflake may travel through many conditions before reaching the ground. Its final shape becomes a soft record of its journey through the cloud. This is why snowflakes can look endlessly varied, even with the same basic symmetry. No two journeys through a cloud are exactly alike. Every flake follows different air currents, temperatures, and moments of changing humidity. Some snowflakes grow broad and flat, like tiny frozen flowers. Others become slender columns, hollow prisms, or simple grains of ice. The most familiar snowflakes have 6 branching arms, spreading from a central point. Their patterns often seem carefully designed, although they form without any guiding hand. They grow through simple physical rules, repeated quietly across microscopic distances. Complex beauty can emerge from very small changes in air and water. You may imagine one crystal turning slowly as it falls. It catches a trace of moonlight, then disappears into the darker air. A snowflake does not always fall directly downward. It may float sideways, rise briefly, or circle inside a gentle current. Its wide shape creates resistance, slowing its movement through the atmosphere. Many flakes fall at only a few kilometers per hour. This slow descent gives them time to drift across rooftops and sleeping forests. Some flakes collide and join together during their journey. These clusters can become the large, soft snowflakes seen during calm winter storms. They settle gently on branches, coats, fences, and quiet, empty roads. When snow reaches the ground, it begins changing almost immediately. Fresh snow contains far more air than solid ice. Between the crystals are countless tiny spaces filled with trapped air. These spaces help create snow's soft appearance and remarkable silence. Sound travels through the air as waves of changing pressure. Hard surfaces reflect many of these waves back toward our ears. Fresh snow behaves differently because its many air pockets scatter and absorb sound. A snowy landscape can therefore seem unusually quiet after a storm. Footsteps become softer. Distant traffic fades, and familiar places feel transformed. The silence is not complete, but many sharp sounds lose their strength. New snow acts almost like a thick blanket placed across the landscape. As snow becomes older and more compact, its quieting effect slowly decreases. The crystals melt slightly, refreeze, and press closer together over time. A smooth, icy crust may even reflect sound more clearly again. But during the first hours after snowfall, the world can feel deeply hushed. This soft silence may be one reason snow feels so peaceful at night. Take another slow breath and let your jaw relax completely. Imagine the gentle quiet of fresh snow surrounding everything outside. Snow also changes the way a winter landscape receives light. Individual ice crystals reflect and scatter much of the light reaching them. Because many wavelengths are reflected together, fresh snow usually appears white. Yet snow is not always a simple, pure white. Under a clear sky, shadows across snow may appear pale blue. The snow absorbs some warmer wavelengths, while scattered blue light remains visible. At sunset, snowy fields can glow pink, lavender, peach, or soft gold. Moonlight can give snow a faint silver color across the night. Even very small amounts of light can brighten a snow-covered landscape. This is why snowy nights sometimes seem brighter than nights without snow. Light from houses, street lamps, stars, and the moon reflects across the ground. The landscape gently returns that light toward the sky and nearby surfaces. In polar regions, this brightness can extend across enormous distances. Snow and ice reflect much more sunlight than dark soil or open water. This reflective quality helps keep snowy regions cooler. Scientists call this reflectiveness albedo, though the effect itself feels beautifully simple. A bright surface returns sunlight, while a dark surface absorbs more warmth. When snow melts, darker ground beneath it begins absorbing additional solar energy. This can encourage further warming and more melting nearby. The quiet brightness of snow is therefore connected to Earth's larger climate patterns. Even a small crystal can participate in the planet's balance of energy. Beneath the snowy surface, another hidden world continues through winter. The ground may remain warmer than the cold air above it. A deep layer of snow can trap heat because its air pockets provide insulation. This creates a protected space between the soil and the colder winter atmosphere. Small animals sometimes move through the sheltered region beneath the snow. Mice, voles, insects, and other creatures use narrow tunnels hidden from view. The snow above protects them from wind and sudden temperature changes. This hidden environment is sometimes called the subnivean space. Inside it, life continues quietly beneath an apparently empty field. Tiny tracks on the surface may reveal only brief signs of movement. A fox may pause, listening for a small animal beneath the snow. An owl may glide above the field almost without sound. Its specialized feathers soften the noise created by moving air. Some winter animals remain active throughout the coldest months. Others reduce their movement and conserve energy in sheltered places. Hibernation is not simply a long and ordinary sleep. For true hibernators, body temperature and metabolism can fall dramatically. Their hearts beat more slowly, and their breathing becomes very gentle. These changes allow stored energy to last through periods with little food. Some animals enter shorter states of reduced activity called torpor. They may awaken occasionally, move, feed, and then rest again. Winter survival takes many forms, each shaped by climate and available shelter. Bears spend long periods resting. Although their winter state differs from deep hibernation, their body temperature falls only slightly compared with smaller, true hibernators. Frogs may remain hidden beneath mud, leaves, or protected water. Certain insects survive as eggs, larvae, or adults sheltered from severe cold. Life does not disappear beneath snow. It becomes quieter, slower, and carefully protected. Let your breathing become even softer now. There is nothing you need to solve during this peaceful winter journey. Snow falling into lakes and rivers becomes part of the water cycle. In mountain regions, winter snow can remain stored for many months. When spring warmth arrives, the snowpack slowly releases water downhill. This melting snow feeds streams, rivers, forests, farms, and reservoirs. A mountain snowfield can act like a natural seasonal water supply. Its water waits quietly until warmer weather allows it to continue moving. Some snowfall remains for years, where temperatures stay low enough. Repeated layers become compressed under the weight of newer snow. The delicate crystals gradually change into denser grains of ice. Over long periods, this compressed snow can become glacial ice. A glacier may appear still, but it moves slowly under its own weight. The movement can be only a few centimeters, or much faster. Glaciers flow across valleys, reshape mountains, and carry rocks within their ice. They store enormous amounts of Earth's fresh water in frozen form. Some glacial ice began as snowfall centuries or thousands of years ago. Tiny bubbles trapped inside can preserve samples of ancient atmosphere. Scientists study these bubbles to understand climates from the distant past. In this way, old snow becomes a quiet archive of the planet. Its layers hold traces of dust, gases, storms, and changing temperatures. Frozen lakes also hide gentle changes beneath their winter surfaces. As water cools, it becomes denser until reaching about 4 degrees Celsius. Below that temperature, it begins becoming less dense again. The coldest water stays near the surface, where it can freeze. Ice floats because solid water is less dense than liquid water. This floating layer protects the deeper water from colder air. Water beneath the ice can remain liquid throughout winter. Fish and other aquatic creatures continue living below the frozen surface. Their world becomes darker and slower, but it does not completely stop. The ice above creates a barrier between the water and winter wind. Snow may collect on the ice, adding another layer of insulation. A frozen lake can seem silent from the shore. Yet the ice may gently expand, contract, or create long, echoing vibrations. These sounds come from changing temperatures and movement within the ice. It may travel great distances across the frozen surface. Tonight, however, we can imagine only the softer side of that winter lake. Snow rests across the ice beneath a calm and clouded sky. Nearby trees stand quietly, holding small white shapes along their branches. Frost forms differently from snow, though both are made from frozen water. Snow develops inside clouds before falling through the atmosphere. Frost grows directly onto cold surfaces near the ground. Water vapor changes into ice without first becoming liquid. Fine crystals appear on grass, windows, stones, leaves, and wooden fences. On very cold mornings, frost can resemble tiny feathers or frozen forests. The shapes depend on temperature, moisture, and the surface beneath them. Window frost may spread in branching patterns across the glass. Each line grows where water vapor meets its surface. Cold enough for freezing, sunlight later warms the window, and the patterns slowly disappear. The water returns to the air, ready to travel again. Snow, frost, clouds, rivers, and rain are all parts of one continuous cycle. Water changes form, but it never truly leaves the larger system. A snowflake may melt into soil and enter the roots of a tree. It may flow into a river, reach the sea, and later rise as vapor. Someday, that same water may return inside another cloud. It could fall as rain, gather as frost, or become snow again. The journey may continue for years, centuries, or far longer. For now, simply rest with the image of snow drifting outside. Let every flake carry one small thought away from you. The winter sky remains patient, quiet, and endlessly spacious. Your breathing can follow the same gentle rhythm as the falling snow. Nothing needs to happen quickly in this peaceful place. The clouds move slowly, the crystals form slowly, and the night deepens slowly. You are warm, safe, and free to rest. Outside, the snow continues settling across the sleeping world. Beyond the quiet window, the snowfall continues beneath a pale and hidden moon. The clouds seem motionless, though gentle currents are carrying crystals through the darkness. Some flakes descend from high, cold layers of the winter atmosphere. Others begin much lower, inside clouds resting softly above hills and forests. A snow cloud may contain water droplets, even when temperatures remain below freezing. These droplets stay liquid because they lack the right surface for crystallization. When a droplet touches an ice crystal, it can freeze almost instantly. Layer by layer, the crystal grows heavier and begins its journey downward. Sometimes the frozen droplets create rounded grains instead of delicate branching snowflakes. These soft grains are called graupel, and they often resemble tiny white beads. They bounce gently when they reach a coat sleeve or wooden windowsill. Their rounded shape tells a different story from the star-shaped crystals nearby. Every form of snow reflects the conditions inside its cloud. Temperature, moisture, wind, and time quietly shape each falling piece. No cloud remains perfectly uniform from its top to its lower edges. A crystal may enter warmer air, then return to colder air again. Its branches may grow quickly in one layer and slowly in another. Some edges remain smooth, while others become elaborate and feathered. The flake becomes a map of changes too small for human eyes to follow. When many crystals fall together, they create the soft curtain we call snowfall. From a distance, the flakes may appear to move in one direction. Closer observation reveals countless small paths crossing and turning through the air. Wind moves around buildings, trees, cliffs, and even other falling flakes. Behind a tree trunk, the air may become calmer. Near a rooftop, small currents may lift snow upward for a moment. A flake can travel sideways farther than it travels downward. It may begin above one field and settle beyond another. Some mountain snow travels many kilometers before finally reaching the ground. The path is slow, wandering, and shaped by invisible movements. Let your breathing wander just as gently without needing a perfect rhythm. Each breath can arrive naturally, then leave without effort. When snow gathers on the ground, the crystals do not remain unchanged. They begin pressing against one another beneath the weight of newer layers. Their sharp branches slowly become rounder as water vapor moves between them. Smaller crystals may fade while larger grains continue growing. This quiet process is called snow metamorphism. The word sounds complex, but the change itself is simple and gradual. Snow is always adjusting to temperature, pressure, and the air within it. A first layer may be light enough to lift with one hand. After days of settling, the same layer can become much denser. Wind can also pack snow firmly against ridges and sheltered walls. In open places, it may remove snow from one area and gather it elsewhere. These gathered shapes are called snowdrifts. A drift can form slowly through many hours of steady wind. Its surface may curve like a frozen wave beside a fence. Around trees, drifts create smooth hollows and rounded white mounds. On high mountains, wind carves snow into long, elegant ridges. Some formations look like waves paused in the middle of motion. Others resemble folds of fabric resting across the land. These patterns reveal the direction and strength of past winds. Even after the air becomes calm, the snow remembers where it traveled. In polar regions, wind can polish snow into hard, shining surfaces. Small ridges called sastrugi may stretch across the frozen ground. They form when wind erodes softer snow and leaves firmer sections behind. Their shapes often point toward the direction of persistent winter winds. Under low sunlight, they create long blue shadows across the white landscape. The polar sun may remain near the horizon for many hours. Its light passes through more atmosphere, becoming warmer and softer. Snowfield can glow with shades of rose, amber, and pale violet. During polar night, moonlight and stars replace the absent daytime sun. The snow reflects these small lights across enormous quiet distances. On clear nights, the aurora may move above the frozen ground. Green and purple light can ripple slowly across the sky. The snow beneath catches a faint trace of those distant colors. The display comes from particles interacting high within Earth's atmosphere. Yet from the ground, it may feel like light breathing across the darkness. There are no trees in the coldest polar interiors. Still, the snow is not entirely empty or lifeless. Microscopic organisms can survive inside ice, snow, and thin films of water. Some remain inactive until sunlight and warmer temperatures return. Others continue very slowly in protected spaces between snow grains. In coastal polar regions, seals rest near openings in the sea ice. Penguins gather closely together to preserve warmth during severe weather. Their outer feathers protect a softer insulating layer beneath. Many polar animals also carry thick layers of fat below their skin. These adaptations reduce heat loss into the cold air and water. Their bodies are shaped by countless generations of winter survival. The snowy world may appear simple, but life has found many gentle strategies. Arctic foxes grow dense winter coats that trap warm air near their bodies. Their fur may become white, helping them blend with snowy surroundings. Their compact ears reduce the surface area exposed to cold air. Even the bottoms of their paws are protected by thick fur. Snowshoe hares also change color as the seasons shift. Their winter coats reflect the brightness of snowy forests. Wide hind feet help spread their weight across soft snow. This allows them to move without sinking as deeply. Caribou use broad hooves to travel across snow and uncover hidden plants. They may brush snow aside to reach lichens beneath the surface. These slow-growing organisms remain valuable during long northern winters. Owls, deer, wolves, and small rodents leave patterns across fresh snow. Tracks reveal movement without disturbing the silence. A line of prints may cross a frozen stream and vanish among dark trees. Another trail may circle a buried seed or sheltered hollow. Snow records these journeys until wind or new snowfall erases them. For a little while, the landscape becomes a quiet page of passing lives. Then the next storm gently clears the page again. Rest your eyes and imagine those tracks becoming softer beneath new snow. There is no path you need to follow tonight. In forests, snow changes the temperature around roots and fallen leaves. A thick layer can protect the soil from the coldest nights. Beneath it, fungi, roots, insects, and microbes remain sheltered. Their activity becomes slower, but important processes continue. Fallen leaves gradually break down within the protected ground. Nutrients remain available for plants when spring returns. Tree roots may stay warmer beneath snow than beneath exposed frozen soil. This insulation can reduce damage from sudden temperature changes. Snow also protects low branches and small plants from drying winter winds. Some alpine plants remain pressed close to the ground beneath deep drifts. Their small size helps them avoid the strongest winds above. When snow melts, they receive moisture at the beginning of their growing season. In high mountains, this season may be very short. A plant may have only a few weeks to grow and flower. Its timing often follows the gradual retreat of the snow. Different slopes lose their snow at different times. Sunny slopes may emerge early, while shaded valleys remain white longer. This creates a slow movement of spring across the mountains. Flowers appear first in one place, then later in another. Insects and birds follow the changing availability of food and shelter. The melting snow guides the rhythm of life without making a sound. Mountain snow also feeds streams that begin as tiny drops beneath the surface. At first, meltwater moves through narrow spaces between crystals. Small channels develop and connect inside the snowpack. The water may disappear below the snow and emerge farther downhill. Many mountain streams begin beneath places that still appear completely frozen. As sunlight strengthens, their flow becomes clearer and more constant. Cold water carries dissolved minerals and tiny particles from the rocks. It moves toward valleys, lakes, forests, and distant communities. The water may later become drinking water, irrigation, or habitat for fish. A quiet winter snowfield can influence landscapes far beyond the mountain. Snowfall patterns depend on the paths taken by air and moisture. Air moving across an ocean or large lake can collect water vapor. When that air reaches colder land, clouds may form quickly. This can create bands of snowfall near large bodies of water. The process is often called lake effect snow. One town may receive deep snow, while another nearby remains almost clear. The difference can come from a narrow cloud band drifting overhead. Mountains can also lift moist air into colder levels. As the air rises, it cools, and some of its moisture becomes snow. The windward side of a mountain may receive frequent snowfall. Beyond the peak, descending air can become drier. This creates different winter climates on opposite sides of the same range. Snow therefore follows the shape of the land as well as the movement of air. Valleys, ridges, oceans, forests, and lakes all influence where it settles. Inside cities, snowfall meets another kind of landscape. Warm roofs may melt flakes before they can gather. Buildings redirect wind into streets, courtyards, and sheltered corners. Snow may collect deeply beside one wall and barely cover another. Streetlights reveal flakes that were invisible in the darkness above. Each flake enters the light briefly and continues beyond it. Warm air from doorways can melt snow into tiny droplets. Cold pavement may preserve it, while darker surfaces absorb more warmth. The city becomes a patchwork of snow, water, ice, and reflected light. Even familiar sounds seem different during a winter storm. Cars move more slowly, and footsteps become measured and soft. Windows glow warmly against the blue-white evening. From indoors, the weather can feel distant and peaceful. Somewhere, a kettle cools beside a quiet lamp. Somewhere, frost begins gathering along the edge of a window. The outside world continues changing while the room remains calm. Snow on rooftops also acts as a temporary layer of insulation. Its trapped air can slow the movement of heat. Yet the exact effect depends on snow depth, density, and the roof beneath. Fresh powder contains more air than old compressed snow. As melting and freezing continue, the layer becomes heavier and firmer. Icicles may form where roof snow melts and water reaches colder edges. Each drop can freeze before falling away. Over time, repeated drops build clear layers of ice. An icicle grows downward, while water continues flowing along its surface. Sunlight may pass through it, bending into soft colors. Small bubbles and cracks make each icicle slightly different. During warmer hours, droplets gather at its narrow tip. At night, colder air may freeze the surface again. The cycle continues until weather or sunlight changes the shape. On tree branches, melting snow follows similar gentle patterns. Drops form beneath twigs and freeze into tiny beads. A branch may hold snow above and clear ice below. When morning sunlight returns, both begin to change. The tree slowly releases the weight it carried through the night. Snow falls from one branch, then another. The forest may briefly whisper as soft clumps reach the ground. A winter forest is not completely silent. It contains faint movements that are easy to miss. Snow compresses beneath an animal's foot. Bark cools and contracts during falling temperatures. A distant branch shifts beneath a layer of white. Wind passes through needles high above the ground. These sounds remain gentle because snow absorbs many sharper echoes. The forest feels enclosed, as though surrounded by soft walls. Let that imagined quiet surround you now. Allow the bed beneath you to feel steady and warm. Cold air itself has qualities that change the feeling of a snowy night. Cold air can hold less water vapor than warm air. This is why winter air often feels dry against skin and lips. Breath contains warm moisture from inside the body. When exhaled into cold air, some moisture condenses into tiny droplets. A soft cloud appears briefly, then fades into the surrounding air. Every visible breath is a small meeting between warmth and cold. Near the ground, dense cold air may settle into valleys overnight. Higher slopes can sometimes remain slightly warmer than the valley floor. This layering of air is called a temperature inversion. It can create mist, frost, or pools of cold beneath clear skies. On still mornings, smoke and fog may remain close to the ground. Snow-covered valleys can hold this quiet atmosphere for hours. The sunlight reaches the peaks before touching the lower fields. Slowly, warmth spreads downward as the morning continues. In open snowfields, sunlight can feel bright even during cold weather. Snow reflects light upward toward the face and sky. This reflected light can be strong enough to affect unprotected eyes. Animals living in bright, snowy environments often have natural adaptations. Some have dark skin around their eyes, reducing reflected glare. Human travelers use tinted lenses to protect their vision. The brightness may seem pure and gentle, but it carries real energy. At night, that same reflective surface becomes softer. Starlight appears clearer above landscapes without many artificial lights. Snow-covered ground can make the horizon easier to see. Dark trees and hills stand clearly against the pale earth. The boundary between land and sky becomes calm and simple. Sometimes, light pillars appear above distant lamps in very cold air. Tiny ice crystals reflect the light into vertical glowing shapes. These pillars may look as though the light continues upward into the sky. They form naturally when flat crystals drift with their faces nearly horizontal. The effect can be golden, white, or faintly colored. It often appears during still, cold nights. Another winter light effect is the halo around the moon. Ice crystals high in the atmosphere bend moonlight at particular angles. The pale ring forms around the moon, wide and softly luminous. The ring may suggest thin clouds and changing weather above. For someone watching from a warm room, it becomes a quiet circle in the sky. Inside that circle, the moon remains calm and distant. Below it, snow continues falling across sleeping fields. Some flakes land whole and preserve their branching shapes. Others break, melt slightly, or join neighboring crystals. Each one becomes part of a larger layer. Individual patterns disappear, yet together they create the winter landscape. This is one of snow's gentlest transformations. Countless delicate forms become one smooth, continuous surface. The field no longer shows every separate flake. It becomes a soft white shape beneath the night. In the same way, separate moments can slowly blend into rest. You do not need to hold each thought or remember each sentence. Let the words settle together without effort. Let them become quiet, distant, and soft around you. The snow outside keeps forming, falling, changing, and returning. Clouds gather water from rivers, lakes, forests, and seas. Cold air shapes that water into crystals for a little while. The crystals travel downward and rest upon the earth. Later, warmth will return them to streams and air. Nothing remains frozen forever, and nothing needs to hurry. For tonight, the water can rest as snow. The forest can rest beneath its white covering. The animals can rest in burrows, nests, hollows, and sheltered trees. And you can rest here, warm within the quiet winter night, far beyond the window. The snow continues its quiet passage through the sleeping air. Some crystals have traveled for hours before reaching the ground. Others formed only recently inside a low winter cloud. Each one carries a brief history of changing temperature and moisture. Under a microscope, a snow crystal reveals details invisible from a distance. Its branches may hold smaller branches, repeating the same six-fold pattern. Some edges appear smooth, while others look finely serrated. Tiny imperfections make the crystal more natural and more individual. Even the most balanced snowflake is never perfectly symmetrical. One arm may enter slightly warmer air than the others. Another may collect more water vapor during a brief turn. These small differences grow as the crystal continues falling. The result is orderly, delicate, and gently unpredictable. Snow crystals often begin as simple hexagonal plates or narrow columns. Their later shape depends strongly on the temperature around them. At certain temperatures, broad plates grow more easily. At others, thin needles or hollow combs become more common. The amount of water vapor also influences their complexity. Dry air may create smaller and simpler crystals. Moist air can encourage wide branches and intricate frozen patterns. A cloud therefore contains many quiet workshops of changing conditions. Each workshop shapes ice in a slightly different way. When crystals fall through warmer air, their edges may begin melting. If they enter colder air again, the droplets can refreeze. This produces grains with rounded surfaces or thin icy coatings. Winter precipitation can change form several times before reaching the earth. A flake may begin as ice, melt into rain, then freeze again. The atmosphere is layered, and every layer offers a different path. Sometimes snow falls from a sky that appears almost clear. Very small ice crystals can form in cold, calm air near the ground. They drift slowly and sparkle when light passes through them. This phenomenon is often called diamond dust. It is especially common in polar regions and cold mountain valleys. The crystals may remain suspended, like faint glitter in the air. They move so gently that the sky itself seems filled with frost. Sunlight can create halos, arcs, and bright points within these crystals. At night, moonlight may produce a softer and quieter glow. Imagine those tiny crystals floating beneath a calm winter moon. Let your breathing become light and easy, like their unhurried movement. Cold fog can also decorate landscapes with ice. Fog contains countless tiny droplets suspended near the ground. When these droplets touch freezing branches, they can become solid. The growing ice is called rime. Rime often forms on the side facing the wind. It can cover trees, rocks, towers, and mountain sides. Its surface may look white, rough, and feathery. On high ridges, rime can grow into long frozen shapes. These shapes reveal where moisture arrived and how the wind moved. A forest coated in rime may appear pale and dreamlike. Every needle and twig becomes outlined with white. The ordinary structure of the tree becomes more visible. Branches that once blended together now carry bright frozen edges. Hoarfrost forms through another quiet process. Water vapor changes directly into ice on very cold surfaces. Large crystals may grow during clear, calm nights. They can appear as feathers, leaves, cups, or delicate blades. On snow, these crystals are sometimes called surface hoar. They catch morning light before wind or warmth changes them. A field of surface hoar can glitter with countless upright crystals. Each one grows from invisible moisture in the nearby air. Nothing falls from a cloud during this process. The frost simply appears where vapor meets the cold ground. Beneath new snowfall, buried frost can become part of the snowpack. Snowpacks are built from many storms and many pauses between storms. Each snowfall creates a layer with its own texture and density. Wind may pack one layer firmly and leave another soft. Sunlight may melt the surface during the day. Nighttime cold may freeze it into a thin crust. Later, snow covers the crust, preserving it beneath the surface. A deep snowpack can contain an entire season of changing weather. Scientists examine these layers to understand mountain conditions. They notice crystal shapes, hardness, temperature, and trapped air. The snow becomes a quiet record of storms, wind, sunlight, and cold. Some layers remain strong and closely connected. Others contain loose grains that do not hold together easily. Over time, temperature differences move water vapor through the snowpack. Warmth from the ground rises gently toward the colder surface. This movement can reshape crystals without melting the entire layer. Large angular grains may grow in hidden spaces below. Snow continues changing even when the landscape seems completely still. Inside every drift, tiny transformations continue through the night. The spaces between grains also contain air. That air moves slowly as pressure and temperature change. Snow can breathe in a very quiet physical sense. Gases pass through its connected pores and narrow channels. This exchange influences the snow, soil, and organisms beneath it. Small amounts of water vapor move upward and downward. Heat travels through the snow much more slowly than through solid ice. This is why soft snow can protect the earth below. The surface may feel bitterly cold beneath the stars, yet several centimeters lower, the temperature can be much steadier. At the base of deep snow, warmth from the ground remains trapped. Plants and small animals benefit from this sheltered boundary. Some insects produce natural substances that protect their cells from freezing. These substances lower the temperature at which body fluids become solid. Other creatures allow controlled freezing within parts of their bodies. Their cells remain protected while ice forms in safer spaces. Wood frogs can survive remarkable periods beneath leaves and snow. Their heartbeat and breathing may pause during deep freezing. When warmer conditions return, their bodies gradually become active again. This survival seems extraordinary, yet it happens quietly each winter. Many insects spend winter in a state called diapause. Their development slows while they wait for favorable conditions. They may shelter inside bark, soil, stems, or fallen leaves. Snow adds another layer of protection above these hidden places. Butterflies may survive winter as eggs, caterpillars, chrysalises, or adults. Different species choose different stages for their long seasonal rest. Ladybirds gather in protected spaces, sometimes resting together in groups. Bees cluster inside their hives and create warmth through small movements. The outer bees gradually exchange places with warmer bees near the center. Their shared activity protects the colony during cold weather. Beneath the snowy roof, the hive remains quietly alive. Winter birds use equally gentle strategies. Chickadees fluff their feathers to trap insulating air. At night, they shelter inside tree cavities and reduce their body temperature slightly. This controlled cooling helps them conserve valuable energy. Other birds gather closely on protected branches. Their feathers create a barrier against wind and cold. Some species hide food during autumn and remember many storage places. Snow may cover these locations, but familiar landmarks guide them. A bird may land beside a tree and uncover one hidden seed, then it disappears again into the quiet forest. Ptarmigans live comfortably in snowy northern and mountain environments. Their feathers become pale during winter, matching the landscape. Feathers also cover much of their feet. These feathered feet spread their weight like natural snowshoes. During severe weather, ptarmigans may rest beneath the snow. They create small chambers protected from cold wind. The snow around them provides insulation and calm. When morning returns, a small opening may appear at the surface. The bird emerges into the blue light of winter. Let your body feel equally sheltered now. The blankets around you can become your own warm layer of snow. Reindeer and caribou experience snow through sound as well as sight. They search beneath it for lichens and other winter food. Their hooves help scrape aside crusted layers. Inside their noses, complex passages warm the cold air they breathe. Heat and moisture are partly recovered before each breath leaves. This reduces the energy lost during long journeys. Their coats contain hollow hairs that trap insulating air. A herd moving across snow may appear slow and steady from far away. Each animal follows paths shaped by memory, weather, and available food. Moose also move through deep snow with long, careful steps. Their wide hooves support them across softer ground. During difficult winters, they remain near sheltered forests. Branches and bark provide food when plants are buried. Evergreen trees offer protection from heavy wind and snowfall. Under their broad lower branches, the snow may be shallower. Small animals use these sheltered spaces as temporary resting places. Trees themselves must also endure the weight of winter. Conifers have flexible branches that bend beneath accumulating snow. Their narrow shape allows some snow to slide away. Needle-like leaves reduce water loss during cold, dry weather. A waxy coating protects them from wind and freezing conditions. Many deciduous trees lose their leaves before winter begins. Without broad leaves, branches collect less snow and lose less water. The tree enters a quiet period of reduced growth. Inside its buds, future leaves and flowers remain protected. Cells contain sugars and other substances that help resist freezing damage. Water movement slows, but the tree remains alive. Its roots continue resting beneath insulated soil. Snow may gather around the trunk, covering moss and fallen bark. During a warmer afternoon, dark bark absorbs sunlight. A thin space may melt around the base of the tree. Later, colder air freezes some of that water again. Small rings of ice can form beneath the snow. These hidden changes continue without disturbing the forest. Snow can also bend young trees toward the ground. When the weight melts away, many gradually rise again. Others remain curved, recording the pressure of past winters. In high mountain regions, trees may grow in twisted forms. Persistent wind shapes their branches toward the sheltered side. Ice and blowing snow remove exposed buds and needles. The resulting forms reveal decades of weather. A mountain tree becomes a living record of cold air and wind. Above the highest trees lies the alpine zone. Here, plants grow close to rocks and soil. Low growth protects them from strong winds and freezing temperatures. Cushion plants form dense, rounded shapes that trap warmer air. Dark leaves absorb sunlight during short mountain summers. Fine hairs protect surfaces and reduce moisture loss. During winter, snow covers these small plants completely. The landscape appears empty, though gardens are resting underneath. When spring arrives, melting begins near exposed rocks. Dark stone warms quickly beneath sunlight. Small circles of bare ground appear around each rock. Flowers may open soon after the snow retreats. Their growing season is brief, so they respond quickly. Some blossoms even appear beside the last melting drifts. Snow and flowers can share the same quiet mountain slope. Higher still, permanent snowfields remain through every season. Their upper layers brighten beneath summer sunlight. Dust and tiny particles slowly settle on their surfaces. Some particles travel great distances through the atmosphere. Desert dust can reach mountain snow thousands of kilometers away. Dark particles absorb more sunlight than clean snow. This can encourage faster melting around them. Even distant landscapes are connected through wind and air. Volcanic ash, pollen, sea salt, and smoke may also enter snow. A clean white field can preserve traces of faraway events. Researchers collect snow samples to study these hidden materials. The amounts are often tiny, but the information can be valuable. Snow gathers particles as it forms and falls. In this way, snowfall gently cleans parts of the atmosphere. Later, melting water carries those particles toward soil and streams. Not all color in snow comes from reflected light. Microscopic algae can sometimes grow within melting snow. Some contain red pigments that protect them from strong sunlight. Large patches may appear pink or reddish during warmer seasons. This is sometimes called watermelon snow. Other algae can create green or orange tones. These organisms remain inactive during the coldest conditions. When liquid water and sunlight return, they begin growing again. They form part of small ecosystems on glaciers and snowfields. Tiny animals and microbes may feed within these colored patches. Even apparently empty snow can support communities of life. Glaciers contain their own hidden environments. Meltwater may create blue pools on the surface. Narrow channels carry water downward through the ice. Some channels open into deep vertical shafts. Below the glacier, streams flow through darkness beneath enormous pressure. Water reduces friction between ice and rock in some places. This can change the glacier's slow movement. At its edge, meltwater emerges carrying fine stone powder. This powder can give glacial rivers a cloudy pale color. When the particles settle in lakes, the water may appear turquoise. The color comes from light scattering through suspended minerals. A mountain lake can therefore hold traces of stone ground by ancient ice. Glacial ice itself often appears blue. Fresh snow contains many air spaces that scatter visible light. As snow becomes compressed, those bubbles become smaller and fewer. Light travels deeper into the dense ice. Red wavelengths are absorbed more readily than blue wavelengths. The remaining blue light returns toward the observer. Deep cracks in old ice can therefore glow with rich blue tones. The color seems almost luminous beneath cloudy skies. Within the ice, trapped bubbles may form long, pale lines. Each bubble holds a tiny sample of air from the past. Layer upon layer, snowfall becomes compressed into a frozen archive. Some ice sheets contain records stretching back hundreds of thousands of years. Their oldest layers rest deep beneath newer snow. The weight above presses the ice outward toward the edges. Although movement is slow, entire landscapes are shaped by it. Valleys become wider, rocks become smoother, and fine sediment is carried away. When glaciers retreat, they leave lakes, ridges, and scattered stones. A quiet snowfall on a mountain may eventually become part of this long process. The transformation takes years beyond counting. For now, imagine only the soft beginning. A small flake settles among many others. More snow arrives and gently covers it. Seasons pass above, While pressure slowly changes its shape, the crystal loses its branches and becomes a rounded grain. Later, it joins clear ice beneath the surface. Its original pattern disappears, but its water remains. Nothing in the journey is wasted. Every stage becomes part of something larger. Take a slow breath and release it without effort. You do not need to follow the snowflake any farther. Frozen lakes continue their own slow winter changes. Ice draws downward from the surface as heat leaves the water. The upper surface remains exposed to changing air temperatures. Snowfall can slow the growth of ice by providing insulation. A clear lake may freeze quickly during cold, snowless weather. A snowy covering can keep the ice beneath slightly warmer. Bubbles sometimes become trapped as the ice thickens. Some come from air released by freezing water. Others come from plants and microbes beneath the surface. In shallow lakes, rising gases may freeze into stacked white circles. The patterns look suspended within clear ice. Cracks may also form as temperatures rise and fall. The ice expands during warmer periods and contracts during colder ones. These movements release energy across the frozen surface. Long tones may travel through the ice like distant musical notes. Lower sounds travel differently from higher sounds. The lake becomes a wide natural instrument beneath winter air. Snow above softens much of this sound for those on shore. Below the ice, fish sense their environment in other ways. Light gradually decreases beneath snow-covered ice. Plants produce less energy during the darkest winter periods. Fish reduce their activity and conserve energy. Some remain near deeper water, where temperatures stay stable. Others continue searching slowly for food. Their movements create faint currents in the cold water. The entire lake enters a quieter seasonal rhythm. Yet oxygen, water, and life continue moving below. Near the shore, reeds may stand frozen into the ice. Their hollow stems provide small pathways for gases. Seeds rest in mud, waiting for warmer water. Frogs and turtles remain sheltered beneath leaves or sediment. The frozen surface protects this resting world from winter wind. Above, snow erases the boundary between lake and land. The shoreline becomes difficult to see beneath white layers. Only trees and reeds suggest where the water begins. Moonlight lies evenly across the entire open space. Clouds move slowly, and the surrounding hills remain dark. In such a place, silence feels wide rather than empty. It holds the hidden lake, the sleeping soil, and the waiting seeds. Let that wide silence settle around you now. Thoughts can become faint shapes beneath a smooth surface. There is no need to reach them or change them. Across the northern oceans, sea ice forms from salty water. As seawater freezes, much of its salt is pushed into the liquid below. The young ice contains narrow channels of concentrated brine. These channels create small habitats for microscopic life. Algae can grow beneath the ice where sunlight still reaches. They provide food for tiny organisms in the polar ocean. Those organisms support fish, birds, seals, and larger animals. A frozen surface can therefore shelter an active world underneath. Sea ice also moves with winds and ocean currents. Large sheets separate, turn, and press against one another. Ridges form where pieces meet and overlap. Openings appear where the ice moves apart. Seals and whales use these openings to reach the air. Polar bears travel across the surface in search of food. Their broad paws distribute their weight and help them swim. The dark skin beneath their fur absorbs warmth from sunlight. Their outer hairs are nearly transparent, though the coat appears white. Light scatters through the fur and creates its pale appearance. Snowy camouflage allows them to blend into the frozen environment. Farther south, ocean snow can fall into warmer water and disappear. A flake touches the sea and melts almost immediately. Its fresh water joins the salt water near the surface. The individual crystal is gone, but the water continues traveling. Ocean currents may carry it across great distances. Sunlight may later lift it into the atmosphere again. The cycle has no single beginning or ending. Water simply moves through air, ice, ocean, soil, and life. Some water remains in the sea for centuries. Some returns to clouds within days. Some becomes part of a plant, animal, river, or glacier. Tonight, we can follow only one gentle part of that endless motion. Clouds gather quietly above a winter landscape. Ice crystals form around particles too small to see. They grow branches within the cold and drifting air. Gravity begins drawing them toward the earth. Wind carries them across forests, lakes, and sleeping towns. They settle on roofs, roads, branches, and open fields. For a while, the world becomes softer and brighter. Sound fades into the spaces between crystals. Tracks appear, cross one another, and disappear. Life continues beneath the white surface. Morning will eventually bring new colors and movement, but the night still has many quiet hours remaining. You can allow your breathing to become slower now. Your body knows how to rest without being instructed. The snow does not try to reach the ground quickly. The lake does not hurry beneath its covering of ice. The forest does not worry about the return of spring. Everything follows its own patient rhythm. Outside, another flake turns once in the moonlight, then it settles softly into the deep and waiting snow. Across the quiet hills, snow gathers in shallow valleys and sheltered spaces. The wind leaves some ridges bare while filling nearby hollows with soft white layers. Every slope receives winter differently, depending on sunlight, trees, and moving air. North-facing slopes often keep their snow longer beneath weaker sunlight. South-facing slopes may warm earlier and reveal dark stones and grasses. These small differences create many winter climates within the same mountain. A few steps can separate firm snow from deep, airy powder. Under trees, intercepted snow rests first upon needles and branches. Some later falls in soft clumps when sunlight warms the canopy. Other snow melts slowly and travels down chunks as clear water. Evergreen forests can therefore hold and release snowfall gradually. Open fields receive snow directly from the sky. There, wind reshapes the surface throughout the night. Small grains roll and bounce close to the ground. They gather behind stones, fences, shrubs, and gentle rises. The growing drifts create smooth curves where the air loses speed. From above, these shapes resemble pale waves crossing the land. Their lines reveal patterns within the invisible winter wind. When wind lifts loose snow without new snowfall, the air can appear misty. This drifting snow remains close to the surface during lighter winds. Stronger currents may carry crystals higher into the air. The original flakes often break into smaller grains during this movement. Their delicate branches become rounded through repeated collisions. Snow on the ground is therefore not always resting. It may travel many times before finding a sheltered place. A single grain can cross a frozen lake or mountain plateau. It may pause behind a rock, then move again the following day. Winter landscapes are slowly rearranged by movements too gentle to notice. Let your thoughts move just as freely tonight. They may appear, drift for a moment, and settle somewhere far away. In calm weather, the surface of snow can grow new crystals. Water vapor rises from warmer layers below and enters the colder air above. Some vapor returns to the surface as delicate frost. The crystals may stand upright like tiny feathers in moonlight. Morning sunlight reveals their edges in brief silver flashes. A light wind can remove them within minutes. Their beauty exists only while the conditions remain perfectly still. Sometimes a thin crust forms above softer snow. Sunlight melts the uppermost grains during the afternoon. Clear nighttime skies allow the surface to lose heat quickly. The melted water then freezes into a smooth and fragile layer. Later snowfall may cover this crust completely. Weeks afterward, it remains hidden within the deeper snowpack. Each layer remembers a different period of winter weather. A storm may leave light powder with large spaces between crystals. A warm afternoon may create denser and wetter grains. Cold wind may produce a firm layer with a polished surface. Quiet nights may add frost between two periods of snowfall. A snowpack becomes a seasonal book written without words. Its pages are made of ice, air, dust, and changing pressure. In spring, these layers soften as warmth travels downward. Water begins moving between grains and connecting small channels. At first, the flow is slow and difficult to see. Later, drops reach the soil and awaken roots beneath the snow. Mountain plants often respond to this first release of water. Buds swell while patches of white remain nearby. Mosses become brighter along the edges of melting drifts. Small insects appear where sunlight warms exposed stones. Birds return to places where food becomes available again. The retreating snow creates a moving boundary between seasons. On one side, winter remains quiet and white. On the other, water, soil, and early growth are returning. This boundary may travel uphill for many weeks. Plants at lower elevations begin growing much earlier. Higher meadows continue resting beneath deep snow. The mountain experiences spring gradually, one elevation at a time. Meltwater also moves beneath the surface before the snow disappears. It follows slopes, roots, stones, and tiny spaces within soil. Some enters underground layers and emerges later as a spring. Some reaches rivers only after months of hidden travel. This delayed movement helps streams continue flowing during dry weather. Snow can therefore influence summer long after winter has ended. A quiet storm in January may become cool river water in August. Its path may pass through forests, farms, and distant towns. Water that once fell as a crystal may nourish leaves and crops. It may enter a lake, rise as vapor, and join another cloud. The cycle continues without preserving the shape of the original flake. Only the water remains, moving gently between many forms. Take a slow breath and allow the bed to support your full weight. Nothing needs to remain fixed, and nothing needs to be carried. Inside clouds, snow can grow beside droplets that remain liquid below freezing. These supercooled droplets are stable until they touch a suitable surface. When they meet an ice crystal, they freeze and add new material. Some crystals collect many droplets and become softly rounded. Others remain clear and sharply branched. A cloud may contain both forms within only a small distance. The temperature inside clouds is never exactly the same everywhere. Rising air cools, while sinking air becomes slightly warmer. Turbulence carries crystals between these changing regions. Their growth speeds up, slows down, or changes direction. The cloud may look simple from the ground. Inside, countless quiet journeys are unfolding at once. Some ice crystals remain too small to fall. They travel with the cloud until they grow heavier. Others begin descending and collect neighboring crystals. When many join together, they form broad and gentle flakes. These larger flakes are common when air near freezing contains abundant moisture. They fall slowly because their shapes resist the surrounding air. From a window, they may seem almost suspended. Each one becomes visible briefly against a dark tree or distant lamp. Then it settles beyond sight upon the growing snow. Dry, colder air often creates smaller and lighter crystals. These flakes may sparkle like fine dust beneath moonlight. They pass through the air quickly and gather in thin layers. Their surfaces can remain loose and powdery for many days. Skiers and mountain travelers describe many kinds of snow. Yet every kind begins with water responding to temperature and air. Powder, crust, grains, slush, and ice are stages of the same substance. The differences come from structure rather than composition. Each form contains water molecules arranged in changing patterns. Even solid ice is not entirely motionless at the molecular level. Molecules vibrate gently within their frozen arrangement. As temperature rises, this movement becomes stronger. At the melting point, the structure begins losing its stability. Some molecules escape into liquid water. Others may move directly into the air as vapor. Snow can slowly disappear even when temperatures remain below freezing. This direct change from ice to vapor is called sublimation. Dry wind and sunlight can remove snow without visible melting. A snowbank may shrink during cold, clear weather. Its water has not vanished from the world. It has simply entered the atmosphere in an invisible form. The opposite process can also occur. Water vapor can become ice directly upon a cold surface. This is how many forms of frost quietly appear. The movement between vapor and ice continues throughout winter. Crystal edges sharpen, soften, vanish, and grow again. Snow is constantly exchanging molecules with the air around it. Its surface is active, even when it appears completely still. On very cold days, footsteps can make snow produce a dry, squeaking sound. The sound depends partly on temperature and crystal hardness. Cold grains resist melting and rub sharply against one another. Under pressure, their brittle edges break and shift. The resulting vibrations create the familiar winter squeak. Warmer snow sounds softer because slight melting reduces friction. A footprint in cold powder may therefore sound crisp and clear. The same footprint during mild weather may sound damp and muted. Snow reveals temperature through sound as well as touch. Its voice changes with the structure of its crystals. Fresh snowfall also changes the acoustics of towns and forests. Sound waves enter the many spaces between loose grains. Part of their energy becomes scattered within the snow. Higher frequencies are often softened more noticeably. This makes the landscape feel less sharp and less distant. A road may seem farther away than it did the previous evening. The movement of a nearby branch may sound unusually close. As snow becomes compacted, the spaces between grains decrease. Its surface reflects more sound instead of absorbing it. An icy winter morning may therefore feel brighter and more echoing. Fresh powder creates one kind of silence. Hard frozen snow creates another, clearer kind of stillness. Both belong to the changing soundscape of winter. Imagine a small village after a nighttime snowfall. Roofs are rounded beneath clean layers of white. Paths have disappeared beneath an untouched surface. Smoke rises slowly from a few warm chimneys. Street lamps create quiet circles of amber light. Snowflakes enter each circle and become visible for a moment. Beyond the lamps, the fields remain pale beneath the clouds. A distant river continues moving beneath dark banks. Its warmer water keeps some sections free from ice. Mist rises where water meets the colder air. The mist freezes lightly on nearby reeds and branches. By morning, each stem carries a fine white outline. The river has decorated its surroundings with invisible moisture. Along the water, winter birds search for open places to feed. Ducks protect their bodies with dense feathers and natural oils. Trapped air within their plumage provides additional insulation. Blood vessels in their legs help reduce heat loss. Warm blood traveling downward passes near colder blood, returning upward. Heat moves between them before reaching exposed feet. This exchange allows birds to stand upon ice for long periods. Their feet remain cooler than the rest of their bodies. Less warmth reaches the ice, so it melts only slightly beneath them. The bird appears calm within a landscape of snow and water. Nearby, beavers may rest inside lodges built from branches and mud. Their entrances remain underwater beneath the winter ice. Stored branches provide food when the surface is frozen. The lodge traps warmth from the animals gathered inside. Snow above adds another layer of insulation. From the shore, the structure may resemble a silent mound. Within it, life continues through darkness and cold. Otters remain active along rivers and coastal areas. Dense fur traps air close to their skin. They may slide across snow between stretches of open water. Their movements leave smooth tracks along sloping banks. A trail may end at a dark opening in the ice. Such marks reveal a brief journey after the animal has gone. Snow holds these records with remarkable clarity. The depth and shape of each print can reveal speed and weight. Soft powder creates deep impressions with blurred edges. Firm snow preserves fine details of claws, toes, and feathers. Sunlight later changes the tracks as their edges begin melting. Nighttime cold may freeze them into harder shapes. New snowfall finally covers them and restores the smooth surface. The landscape forgets each journey in its own gentle time. You can let the day fade in the same way. Each memory may soften beneath the quiet snowfall of rest. In northern forests, snow collects differently beneath various trees. Dense spruce branches intercept more flakes than bare deciduous limbs. This creates sheltered circles where the snow remains shallower. Small mammals may use these spaces to search for seeds. Birds may rest within the dense branches above. The canopy reduces wind and slows the loss of warmth. No resting on branches can also protect needles from severe cold, yet heavy, wet snow places more weight upon the tree. Flexible branches bend and release some of the accumulation. Soft thump may follow as snow falls to the ground. The branch rises slowly after losing its white covering. In warmer snowstorms, flakes contain more liquid water. They cling easily to bark, wires, fences, and stone walls. The landscape becomes outlined with thick white forms. In colder storms, dry crystals may pass through branches more easily. They settle loosely and are quickly moved by wind. Two storms can cover the same forest in completely different ways. One creates heavy, rounded shapes and quiet, drooping branches. Another creates fine powder and sharp, delicate shadows. Winter light changes these scenes throughout the day. Before sunrise, snow often appears blue beneath the open sky. The blue comes partly from light scattered through the atmosphere. Snow shadows receive more skylight than direct sunlight. When the sun reaches the horizon, warm colors spread across the surface. Pink light touches high peaks before reaching lower valleys. For several minutes, mountain snow may appear softly luminous. This glow is sometimes called alpenglow. It can appear before sunrise or shortly after sunset. The mountains receive warm light, while the observer remains in shadow. As the sun climbs higher, the colors become whiter and brighter. Tiny crystals flash as their flat surfaces face the light. Every sparkle lasts only an instant. A different crystal then turns and produces another point of brightness. The field seems filled with countless small lights. At night, those sparkles become quieter beneath the moon. The moon reflects sunlight, though its glow feels cooler to human eyes. Snow returns that faint light across the ground. Darkness remains, but the shapes of hills and trees stay visible. A cloud passing over the moon changes the scene again. The landscape dims, and distant details slowly disappear. When the cloud moves on, silver light returns to the snow. This gentle rhythm can continue throughout the winter night. Let your breathing follow that slow change between brightness and shadow. Each inhale can arrive like moonlight returning across a field. Each exhale can fade like a cloud moving softly overhead. In polar regions, snow may remain for many years without melting completely. New layers bury old surfaces and press them into denser material. After 1 year, old snow is often called firn. Firn lies between fresh snow and solid glacial ice. Its grains have become rounded and closely packed. Air still remains between them, though the spaces continue shrinking. With greater depth, pressure closes many of these passages. Some air becomes sealed inside small bubbles. The snow has now begun becoming true glacier ice. The change may take decades or longer. Cold regions preserve this process within vast white interiors. Each year adds another layer above the last. The layers may be thin during dry years. Stormier years may leave thicker bands. Dust, volcanic particles, and sea salts mark certain periods. Researchers read these patterns like distant seasonal memories. The ice preserves information because movement is slow, and temperatures remain low. Deep below, pressure gradually reshapes the crystal structure. Individual ice crystals grow, rotate, and press against neighboring crystals. The glacier behaves as a solid over short moments. Across centuries, it flows like an extremely slow river. Gravity draws it toward valleys, coasts, and lower ground. The movement may create long cracks where the surface stretches. Snowfall later softens their edges and fills smaller openings. At the glacier's end, melting returns ancient ice to liquid water. A drop may emerge after remaining frozen for thousands of years. It enters a stream beneath the same sky that once formed its snow. The air, mountains, and living world may now be entirely different. Yet the water continues its familiar journey. It moves downhill, reflects light, and joins other water. Nothing announces the age of the drop. It simply becomes part of the present river. This long transformation can feel peaceful when imagined slowly. Snow becomes ice, ice becomes water, and water becomes cloud. Cloud becomes snow again beneath another winter sky. Rest inside that simple cycle for a little while. There is no beginning you need to remember. There is no ending you need to reach. Outside, the night remains cold, quiet, and spacious. Snow continues gathering in the sheltered hollows of the land. The deepest drifts become smoother as each new flake arrives. Tree branches hold pale lines against the dark forest. A frozen river reflects a narrow opening between the clouds. Animals rest beneath roots, inside trees, and under insulated snow. Water waits within mountains for the warmth of another season. And here, within the stillness, your breathing remains gentle and unhurried. The winter world asks nothing from you tonight. You may simply listen, soften, and slowly drift toward sleep. The winter night stretches quietly across distant fields, frozen lakes, and sleeping mountain valleys. Clouds drift slowly above, carrying water gathered from oceans, forests, rivers, and soil. Some of that water has traveled through the atmosphere many times before becoming snow tonight. A single molecule may once have rested inside a warm summer sea. Sunlight lifted it gently into the air as invisible vapor. Wind then carried it over coastlines, hills, and wide stretches of land. It may have joined rain, entered a river, or passed through the roots of a tree. Now it has reached a cold cloud and become part of a tiny ice crystal. Water remembers no single shape for very long. It becomes vapor, cloud, rain, frost, snow, rivers, and living cells. Every change is temporary, though the journey itself continues. You may let your thoughts become temporary shapes as well. They can appear softly, change, and disappear without needing your attention. High inside the cloud, the newly forming crystal begins around a microscopic particle. That particle may be dust, pollen, sea salt, or material carried by distant winds. Without such particles, water can remain liquid even below its usual freezing temperature. The small surface gives water molecules a place to arrange themselves into ice. Once the first crystal forms, nearby vapor begins joining its edges. Growth occurs most easily along 6 directions. The crystal develops its familiar hexagonal structure, though its final form remains uncertain. Air currents lift it upward, carry it sideways, and allow it to descend again. Each movement places the crystal within slightly different conditions. A colder layer may encourage thin columns. A moister layer may produce broad plates with branching arms. The crystal can change its style several times before leaving the cloud. Its appearance becomes a quiet record of places no human observer could follow. Some snow crystals remain simple throughout their journey. They arrive as small plates, prisms, or narrow needles. Others develop intricate branches that spread outward like frozen ferns. Large, elaborate crystals require enough moisture and time to grow. Their fragile arms can break when they collide with neighboring crystals. The pieces may continue falling separately or attached to other flakes. A snowstorm therefore contains complete crystals, broken fragments, and clusters joined together. From the ground, they all become part of the same soft descent. Imagine standing beneath that snowfall without feeling any cold. The flakes move through a pool of gentle lamplight. Some appear sharply for a moment, while others remain soft and distant. Their paths cross, turn, and disappear into darkness. No 2 flakes arrive at exactly the same speed or angle. Yet together, they create the steady impression of falling snow. The mind often sees unity where countless small events are unfolding. A storm seems like one thing, though it contains millions of separate journeys. A forest seems still, though every branch and living cell continues changing. Rest can feel motionless, though breath and heartbeat quietly continue. Let your breathing remain natural and unmeasured. Your body already understands the slow work of the night. When snow lands on another flake, their branches hold them slightly apart. This creates a deep layer filled mostly with air. Fresh powder can contain surprisingly little solid water. Its airy structure makes it light, insulating, and effective at softening sound. The ground beneath may remain much warmer than the exposed snow surface. Heat from the soil travels upward, but becomes trapped among countless air spaces. Small creatures use this protected region during severe winter weather. Beneath the white surface, temperatures remain steadier than in the open air. Voles build tunnels between the soil and the lowest snow layers. They search for seeds, roots, bark, and other winter food. Their tunnels may connect resting chambers with protected feeding areas. Above them, the field appears smooth and empty. Only a small opening or faint depression may reveal the hidden world. Shrews also move beneath the snow, hunting insects and tiny invertebrates. Their metabolism remains fast, so they must continue finding food. Snow protects them from wind and helps conceal them from some predators. Yet foxes and owls can sometimes detect movement below. A fox may stand silently with its ears directed toward the ground. Its hearing locates faint rustling beneath the snow. Then it may leap upward and disappear briefly into the powder. The moment is sudden, but the winter night soon becomes quiet again. Owls use remarkably sensitive hearing to find hidden prey. Some species have ear openings, positioned at slightly different heights. This helps them judge the direction and distance of small sounds. Their broad wings carry them above the snow with very little noise. Special feather edges break moving air into smaller, quieter currents. The owl can listen without masking the sounds beneath it. After passing overhead, it becomes a pale shape among dark trees. The forest returns to its patient stillness. Larger animals also change their movement during deep winter. Deer follow established paths where repeated steps have compressed the snow. These narrow trails reduce the energy required for travel. A single path may be used by many animals throughout the season. Snow beside the trail remains deep, while the center becomes firm and smooth. The path links feeding places, water, and sheltered resting areas. At night, the trail may hold prints from several different species. A hare crosses quickly, leaving long paired marks. A fox follows later with a narrow line of careful steps. Small birds land briefly and leave tiny star-shaped impressions. Wind softens every edge before morning. New snowfall may cover the entire collection within minutes. Snow records movement, but it does not preserve it forever. Its surface accepts every visitor and releases every trace. You may allow today's remaining impressions to fade in the same way. There is no need to keep every conversation, task, or unfinished thought. Let a quiet layer of snow settle over them. In sheltered woodland, red squirrels remain active during many winter days. They store cones, nuts, and seeds before the coldest weather arrives. Some food is hidden in many separate locations. Other supplies are gathered within larger protected stores. The squirrel relies on memory and scent to recover them beneath snow. Not every hidden seed is found again. Some remain in the ground and may later begin growing. A forgotten winter meal can become a young tree. This quiet accident helps forests renew themselves. Jays and other birds also hide seeds across wide territories. Their remarkable memories guide them back to many locations. Those they overlook may take root when warmth returns. Winter preparation and spring growth are gently connected. Snow protects many of these buried seeds from sudden temperature changes. Within the seed, the future plant remains inactive. Its outer covering protects a small living embryo. Moisture and warmth will eventually begin the process of germination. For now, waiting is the correct and natural response. Nothing within the seed struggles to become a tree during the frozen night. It rests until the world provides the necessary conditions. Across the forest floor, bulbs and roots wait in similar stillness. Stored energy remains beneath the soil. Snow covers the ground, while future leaves remain hidden. The visible landscape seems empty, but it contains many beginnings. Rest is not the absence of life. It is often a quiet part of growth. Take a slow breath and let that thought pass gently. There is nothing unproductive about resting deeply tonight. In mountain forests, heavy snow influences the shape and location of trees. Some seedlings survive beneath the protective cover of larger branches. Others grow where wind repeatedly clears the ground. Snow can bend young trunks and press low branches against the earth. When spring arrives, many rise gradually as the weight disappears. Trees growing near the upper limit of forests face severe wind and cold. They may develop low, twisted forms close to the ground. Branches survive better on the sheltered side of the trunk. The exposed side loses needles and buds to blowing ice. Over many years, the tree takes on the shape of prevailing weather. Its form becomes a visible history of invisible wind. Above the final trees, snow spreads across open alpine slopes. Rocky ridges interrupt the smooth white surface. Wind gathers powder behind each stone and removes it from exposed places. Lichens cling to rock beneath thin films of moisture. They grow extremely slowly in the harsh mountain environment. Some may live for decades or centuries. Snow protects them during part of the year. When exposed, they tolerate sunlight, dryness, and severe temperature changes. Their quiet persistence helps prepare rock for future soil. Tiny particles loosen, organic material gathers, and small plants eventually appear. A landscape can change through processes almost too slow to notice. The same mountain may seem permanent during a human lifetime, yet snow, ice, water, roots, and wind are always reshaping it. Water enters small cracks within the rock. When it freezes, it expands slightly. Repeated freezing and thawing can gradually widen the cracks. Small pieces eventually separate from the larger stone. They move downhill through gravity, streams, and glacial ice. The process may require hundreds of winters. Each cold night contributes only a little. Small changes repeated patiently can transform an entire valley. Glaciers perform this work on a larger scale. Snow gathers where more falls each year, then melts away. The lower layers become compressed beneath continuing accumulation. Soft snow changes into firn, then into dense glacial ice. Gravity causes the ice to deform and flow downhill. The glacier carries stones frozen within its base and sides. These stones scrape the ground as the ice moves. Valleys become deeper and broader over long periods. Sharp mountain landscapes are gradually given smoother curves. Glacial movement may be slow, but it is never completely absent. Even during winter, pressure continues acting within the ice. Crystals shift and adjust against one another. Meltwater may remain within deep channels or near the glacier's base. Snowfall above adds new material to the frozen river. One winter storm becomes part of a journey lasting centuries. Eventually, the ice reaches a warmer elevation and begins melting. The released water enters streams filled with fine mineral particles. These particles were created by stone grinding slowly beneath the glacier. They can remain suspended and scatter blue-green light. This gives some glacial lakes their clear turquoise appearance. The calm color carries a history of ice, pressure, and ancient rock. During winter, the lake may freeze beneath fresh snow. Its bright summer water disappears below a quiet white surface, yet liquid remains beneath the ice. The lake enters another stage of its yearly rhythm. Freezing begins at the surface because cold air removes heat from the water. Water behaves unusually as it approaches the freezing point. It reaches its greatest density before becoming ice. Slightly warmer, denser water sinks below the colder surface layer. The upper water eventually freezes and floats. This floating ice prevents the entire lake from freezing quickly. It separates the deeper water from the coldest air. Fish remain within liquid water below. Their body temperatures follow the temperature of their environment. Many become less active and require less food. They gather in areas where conditions remain stable. Some species continue moving beneath the ice throughout winter. Their slow fins create currents invisible from above. Aquatic insects remain within mud, plants, and deeper water. Microscopic life continues processing nutrients. The frozen lake is quiet, but it is not lifeless. Light passing through ice and snow becomes weaker with depth. A clear ice surface allows more light into the water. Thick snow reflects much of that light back toward the sky. The underwater world becomes dim and blue. Plants reduce photosynthesis during the darkest periods. As days lengthen, more light gradually returns. Before the ice melts, the lake already senses the approaching spring. Daylight increases minute by minute. Changes begin long before they become visible on shore. Beneath the snow, Similar preparations occur within soil. Temperature rises slowly as sunlight strengthens. Meltwater appears along darker rocks and tree trunks. The first drops move downward through old snow. They refreeze during colder nights and melt again the next afternoon. This daily rhythm creates layers of clear ice and coarse grains. Snow becomes heavier as liquid water fills its air spaces. The surface loses its soft, powdery texture. Small streams begin flowing beneath the remaining white cover. Their sound may be heard before the water becomes visible. A faint trickle travels below the snow. Then a dark opening appears, bordered by rounded crystals. Water returns to the open air after months of stillness. The transition from winter to spring happens gradually. One warm day does not remove an entire season. Snow remains in shaded forests and deep mountain hollows. North-facing valleys may stay white, while nearby fields become green. These remaining patches release water slowly. Their cool edges create small habitats for specialized plants and insects. Some animals follow the retreating snow toward higher elevations. They find fresh growth wherever the white surface has recently melted. The snowline becomes a moving source of water and food. Winter does not simply end. It travels upward and disappears one quiet place at a time. Farther north, summer may arrive without removing all the snow. May. Permanent patches remain where wind gathers deep drifts. Their oldest layers can survive for many years. Pollen, leaves, feathers, and dust become trapped within them. These materials preserve traces of earlier seasons. Melting may later reveal objects hidden long ago. The snow has acted as a cold and patient container. In polar ice, preservation can continue for far greater periods. Snow compresses into layers that hold signs of ancient climates. Small bubbles capture the composition of earlier atmospheres. Dust reveals distant dry periods and powerful winds. Chemical traces may mark large volcanic eruptions. Each layer contains information from a world that no longer exists. Scientists recover long cylinders of ice, called cores. They examine the layers without needing to witness the original snowfall. The ice becomes a message carried quietly through time. A snowflake that once fell unnoticed can contribute to human understanding centuries later. Yet tonight, there is no need to think across centuries. Return gently to the simple image beyond the window. Snow continues falling through calm and darkened air. The nearest flakes appear large and soft. Those farther away become tiny points against the sky. A branch bends slightly as another layer gathers. The roof holds a smooth white curve beneath moonlight. Footprints from earlier have almost disappeared. The road is quieter, and the sleeping houses seem farther apart. Inside each home, warmth remains behind windows and walls. Outside, the cold air moves gently across the new snow. The storm may continue until morning, or the clouds may thin before the night is over. Either way, the snow has already changed the landscape. It has softened edges, covered paths, and brightened the darkness. It has protected roots, stored water, and carried moisture from distant places. It has created shelter for small animals beneath the surface. It has joined the beginning of streams, lakes, and future glaciers. All of this happens without hurry. Let your body follow the same unhurried rhythm. Your muscles can soften gradually rather than all at once. Your breath can become quieter without being controlled. Thoughts may continue falling, but they do not need to remain. Each one can settle gently beyond your awareness. The night is spacious enough to hold everything. The snow is deep enough to soften every distant sound. You are warm, supported, and allowed to rest. Beyond the glass, the winter world continues its quiet transformations, and beneath the falling snow, countless forms of life wait peacefully for morning. The snowfall has become lighter now, though the winter sky remains softly covered. Only a few flakes pass the window, turning slowly through the blue darkness. Each one appears for a moment, then joins the quiet ground below. After a storm, the atmosphere often begins settling into gentler layers. The strongest winds move onward, leaving colder and calmer air behind. Clouds may thin until the moon becomes visible through a pale veil. Its light spreads across the snow without creating sharp shadows. The entire landscape seems to breathe more slowly beneath that silver glow. Allow your breathing to soften with it without counting or controlling anything. The night can carry the rhythm for you. When clouds move away, snow can cool rapidly beneath the clear sky. The surface releases heat upward into the open atmosphere. Fresh snow contains many air pockets, which slow heat rising from below. This allows the uppermost crystals to become colder than the surrounding air. Water vapor may settle onto them and create new frost. By morning, the surface can hold delicate crystals that were absent before midnight. They stand like tiny leaves or feathers above the older snow. A low sun may illuminate them from behind. For a few quiet minutes, the ground appears covered with small glass gardens. Then wind, warmth, or new snowfall changes everything again. Snow is always temporary in shape, even when winter lasts for months. The crystals continue exchanging water molecules with the air. Some grains shrink, while neighboring grains slowly become larger. Sharp branches gradually soften into rounded forms. The snow settles lower as the open spaces between crystals decrease. A deep snowfall may lose much of its height without melting. Gravity gently presses every layer closer together. The surface seems still, but the structure underneath is slowly rearranging. This settling can continue for days after the final flake has fallen. The process creates subtle changes in how snow reflects light. Fresh powder scatters light through countless irregular surfaces. Older snow may sparkle more brightly as larger grains develop. Partly melted snow can look almost glassy under afternoon sunlight. After freezing again, it may form a clear and shining crust. Every stage has its own texture, color, and quiet sound. Cold powder brushes softly beneath a passing animal. Wet snow presses into heavy, rounded footprints. Frozen crust may support a small bird without breaking. A larger animal may step through and reveal the softer layer below. These differences shape how creatures travel across winter landscapes. Snowshoe hares spread their weight across broad, fur-covered feet. Their long hind feet remain near the surface of deep powder. This helps them move with less effort through northern forests. During winter, their coats become pale and dense. The color blends with snow, while the fur traps insulating air. A hare resting beside a snowy shrub can become almost invisible. Only a dark eye or small movement may reveal its presence. Its ears remain alert to the quiet sounds around it. When the forest feels safe again, it continues along a familiar trail. Lynx also have wide paws adapted for movement across deep snow. Their feet act like natural platforms beneath their soft winter coats. They follow hares through forests, though their movements remain patient and measured. A lynx may pause for long periods beneath snow-covered branches. Its thick fur protects it from the cold air. Tufts along its ears shift gently in the faint wind. Then it steps forward, leaving broad prints across the white ground. The tracks may remain until the next snowfall arrives. Other animals choose not to travel at all during severe weather. Grouse can dive beneath loose snow and create sheltered chambers. The snow blocks wind and holds warmth around the resting bird. A small tunnel connects the chamber with the surface. Inside, feathers trap another layer of warm air. The temperature remains milder than the exposed night above. Before morning, the bird may quietly emerge from its snowy shelter. A soft hollow remains where it spent the darkest hours. Small mammals create more permanent networks below the surface. Their tunnels follow grasses, roots, fallen branches, and uneven ground. Snow forms the roof of this hidden winter landscape. The air inside stays humid and relatively stable. Plants beneath may remain green, despite the colder world above. Mice feed on seeds stored during autumn. Voles chew bark, stems, and protected roots. Insects and spiders remain hidden among leaves and soil. Predators may hear this movement, but most activity remains unseen. So, a smooth field can contain many paths beneath its surface. The white landscape is therefore not empty. It is layered with shelter, movement, waiting, and quiet survival. Take a gentle breath and imagine the warmth beneath that snow. Your own blankets can hold warmth just as softly around you. In the far north, snow becomes part of the architecture of winter. People have long understood its ability to slow the movement of heat. Compressed snow can contain enough trapped air to provide useful insulation. Walls made from carefully shaped blocks reduce exposure to strong wind. Warmth from people and lamps remains inside the enclosed space. The outer surface may stay frozen while the interior becomes comfortable. Snow seems cold to the touch, yet it can protect against colder air. This gentle contradiction comes from its unusual structure. Air does not carry heat efficiently when held within small, still spaces. The same principle allows snow to protect soil, plants, and animals. It also explains the warmth held inside feathers and thick fur. Nature often keeps warmth by trapping quiet pockets of air. Beneath a snow-covered forest, leaves create another insulating layer. The ground stores heat gathered during warmer seasons. Snow slows the loss of that remaining warmth. Soil temperatures may stay close to freezing even during colder nights. Roots experience less extreme change than branches exposed above. Microorganisms continue working slowly within the protected earth. They break down organic material and return nutrients to the soil. Their activity may be reduced, but it does not stop completely. Carbon, minerals, moisture, and life continue moving beneath the snow. When melting begins, these materials enter roots and flowing water. Spring growth depends partly on winter processes hidden from sight. Snow also carries small amounts of material from the atmosphere. As flakes fall, they collect dust, salt, pollen, and other particles. The air after snowfall may therefore feel especially clear. Some suspended particles have been brought gently to the ground. They remain within the snow until melting releases them. A snow sample can contain traces from nearby forests or distant oceans. Sea salt may travel inland inside clouds in winter storms. Dust can cross continents before settling onto a mountain. Pollen from a past season may remain preserved in frozen layers. Even remote snowfields receive visitors from faraway landscapes. The atmosphere connects places that appear completely separate. A grain of desert dust can rest beside a polar ice crystal. A particle from ocean spray can settle on a mountain ridge. Wind carries these materials without regard for borders or distance. Snow receives them quietly and holds them for a while. Researchers sometimes examine snow chemistry to understand the atmosphere above. Different layers reveal changes in wind, pollution, storms, and seasonal conditions. Yet to the eye, the surface still appears simple and white. Much of nature's complexity remains hidden inside peaceful forms. A snowfield can look empty while containing countless stories. That silence does not mean nothing is happening. It simply means the changes are small, slow, and widely scattered. In cities, snowfall gathers a different collection of particles. Fresh snow often appears brightest during its first hours. Over time, traffic and air deposit darker material upon it. The snow absorbs more sunlight as its surface darkens. Melting may begin sooner in these altered places. Along roads, salt is sometimes used to lower the freezing temperature of water. Salt dissolves within a thin liquid layer on the ice. This makes freezing more difficult at certain temperatures. The process changes clear ice into wet slush. Far from roads, natural salts also influence freezing. Seawater freezes below the usual freezing point of freshwater. As ice forms, much of the salt remains within the liquid ocean. The rejected salt makes nearby water denser. That colder, saltier water can sink beneath the surface. In polar oceans, this movement contributes to large patterns of circulation. Water from the surface begins a deep journey through the sea. It may travel for centuries before returning upward. The freezing of sea ice is connected to motion far beyond the polar shore. A thin sheet forming beneath a dark sky can influence distant oceans. Earth's systems are often linked by slow and invisible pathways. Snowfall on land creates similar connections through rivers. A mountain storm may later supply water to a valley far away. The snowpack releases moisture gradually as days become warmer. Some water enters streams immediately. Some sinks into soil and moves through underground rock. It may emerge months later from a cool spring. Groundwater can continue feeding rivers after surface snow has disappeared. This delayed release helps landscapes through dry periods. Snow is therefore a kind of seasonal storage. Winter places water gently upon mountains and high plateaus. Spring and summer unlock it a little at a time. The timing depends on temperature, sunlight, wind, dust, and snow depth. A shaded forest holds snow differently from an open meadow. Dense trees reduce sunlight, though their branches intercept some snowfall. Open fields receive more snow, but also more direct warmth. Deep valleys may keep cold air pulled near the ground. Warm winds can remove snow rapidly from exposed slopes. Every landscape releases winter water according to its own shape. Some snow melts at the surface under sunlight. Some melts from below where the ground remains warm. Water can also condense from humid air onto the snow. Rain may enter an older snowpack and move through its layers. The water follows small channels between rounded grains. These channels grow and connect as melting continues. Eventually, drops reach the soil and begin moving downhill. Beneath the snow, the first streamlets may flow through darkness. They create soft spaces where crystals disappear. A person standing above may hear only a faint, distant murmur. The sound is spring beginning before the landscape looks different. At night, colder temperatures slow the melting. The channels may partly freeze and become lined with clear ice. When sunlight returns, water begins moving again. This daily pause and release creates a gentle seasonal rhythm. Winter loosens its hold through thousands of small cycles. A shaded snowbank may survive long after nearby fields become bare. Its edges become thin, uneven, and filled with pine needles. Water drops steadily from the lower side. The last patch may disappear during an ordinary afternoon. No clear moment announces that winter snow has ended. One day, The ground is simply visible where white once remained. Grasses rise, flattened but still alive. Leaves soften after months beneath the frozen cover. Moss absorbs water and becomes bright again. Small shoots begin reaching toward the returning light. The water from snow enters every new green surface. In colder highlands, this awakening begins much later. Snowfields remain beneath long summer days. Near their melting edges, specialized insects may become active. Tiny, dark creatures sometimes appear upon the snow itself. Springtails, sometimes called snow fleas, can gather on warm winter days. They are not fleas, and they are harmless to people. Their dark bodies absorb sunlight against the white surface. They feed on microscopic material within soil and decaying plants. A fourth structure beneath their bodies allows them to jump. From a distance, they may resemble moving grains of pepper. Their presence is another reminder that snow supports unexpected life. Certain spiders and insects remain active at surprisingly low temperatures. Sunlight can warm their dark bodies above the surrounding air. They move briefly across the snow, then return to sheltered spaces. Birds may search for them along melting edges. Life responds quickly whenever a small opportunity for warmth appears. In high mountain regions, snow algae also awaken during warmer periods. Microscopic cells grow within thin layers of liquid water. Their pigments may turn the snow pink, red, green, or orange. The color protects them from intense sunlight. Each cell is tiny, though many together create visible patches. These algae support other microscopic organisms living on snowfields. Their darker color can also absorb additional solar energy. The surrounding snow may melt slightly faster. A living community can therefore change the frozen surface beneath it. Even glaciers are not entirely separate from biology. Microbes live in small water pockets, sediments, and cracks. Some survive with very little light or available energy. Wind carries cells and nutrients onto the ice. Meltwater gathers them within shallow pools. Dark sediments form small holes as they absorb sunlight. These holes may contain water and microscopic ecosystems. To a distant observer, the glacier appears silent and empty. Up close, it contains many small habitats. Life finds narrow spaces wherever water and energy become available. Some microbes remain frozen for long periods. Others become active only during brief summer melting. The boundary between living and resting can become very gentle. A cell may slow until its activity is almost impossible to measure. When conditions improve, its quiet chemistry begins again. This ability to wait is common throughout winter ecosystems. Seeds wait beneath soil. Buds wait inside protective scales. Insects wait within bark and leaves. Frogs wait beneath mud. Bears wait within sheltered dens. Trees wait with water held carefully inside their tissues. The landscape appears paused, but every organism remains connected to time. Day length changes even during the coldest weeks. The sun rises slightly earlier or sets slightly later. Plants and animals can sense these gradual differences. Hormones shift, migration begins, and stored energy is used differently. Spring starts as a change in light before becoming a change in temperature. Snow may still cover everything when these hidden preparations begin. The forest knows the season is turning before human eyes notice. Birdsong may return while branches remain white. A woodpecker's tapping carries across the snow. A small bird tests a few notes during a brighter morning. The sounds are separated by long periods of silence. As days lengthen, the forest gradually becomes more vocal. For tonight, however, The darkness remains deep and calm. The animals are resting, and the branches hold their snow. Let your mind remain with the quieter part of the season. There is no need to move toward morning yet. Snow also changes the familiar shapes of objects. A stone becomes a smooth white mound. A fallen log becomes a long and rounded ridge. Low shrubs disappear beneath curved surfaces. Fence posts remain as small, dark marks across the field. The landscape becomes simpler because many details are hidden. This visual simplicity may contribute to the peaceful feeling of snow. Fewer edges and colors compete for attention. The world seems reduced to light, shadow, and gentle form. Moonlit snow can make distances difficult to judge. A nearby slope may blend with the field beyond it. Cloud and ground can share similar shades of white. Dark trees become the clearest points within the scene. Their trunks provide vertical lines against the open surface. A single warm window becomes especially noticeable. Its golden light contrasts softly with the blue winter night. Inside, ordinary objects remain warm and familiar. A chair stands near the window. A blanket rests across the edge of a bed. A cup cools slowly on a nearby table. Outside, snow settles along the window frame. Small flakes melt when they touch the warmer glass. The droplets join together and move downward. Near the colder edges, frost may remain. The same window holds liquid water, ice, and vapor within a few centimeters. Warmth from the room meets cold air from outside. The boundary creates patterns that change throughout the night. A thin area of mist appears and fades on the glass. Frost grows where the surface becomes cold enough. Its branches resemble tiny plants or feathers. These shapes are not snowflakes, though both reflect the structure of ice. Water molecules follow the same, six-sided arrangement. The surrounding conditions determine how that arrangement becomes visible. On a window, crystals grow along the cold surface. Inside a cloud, they grow while floating through open air. On the ground, they grow as frost upon existing snow. The same simple molecular pattern creates many forms of winter beauty. Hexagons appear in plates, columns, branches, and delicate stars. The structure begins with the shape of a water molecule. Each molecule contains one oxygen atom and two hydrogen atoms. Their arrangement gives water unusual electrical properties. Molecules attract one another and form temporary bonds. In ice, these bonds create an open crystal framework. The open structure takes more space than liquid water. This is why water expands as it freezes. It is also why ice is less dense and floats. Because lake ice floats, it forms a protective layer above liquid water. Without this unusual property, winter lakes would behave very differently. Ice might sink, and freezing could continue from below. Instead, floating ice separates deep water from the cold atmosphere. Life remains sheltered beneath the surface. A small molecular arrangement helps preserve entire freshwater ecosystems. Snow's six-sided beauty and floating lake ice share the same origin. Both emerge from the gentle geometry of water. This geometry also creates the expansion that breaks rock during freezing. It shapes mountains while protecting fish beneath winter lakes. A single property can have many effects across the planet. Nature rarely keeps its processes within one simple category. The structure of ice influences weather, landscapes, rivers, animals, and human life. Yet these connections can remain quiet and easy to imagine. A molecule joins a crystal inside a cloud. The crystal falls onto a mountain. The snow becomes glacier ice. The glacier shapes a valley. Meltwater enters a lake. Lake ice floats through winter. A fish remains alive beneath it. Everything begins with small relationships repeated over time. Let that thought become distant and soft now. You do not need to remember the details. Allow the images to remain without effort. A cloud, a crystal, a mountain, and a frozen lake. Each can drift through your mind and quietly disappear. The sky outside has become clearer. Only a few clouds remain near the horizon. Stars appear above the snowy fields. Their light began traveling long before tonight's snow formed. It crosses immense distances before touching the small crystals below. The snow reflects a tiny portion back toward the darkness. For a moment, ancient starlight rests upon new snow. A fox crosses the field beneath that distant light. A bird sleeps inside the shelter of an evergreen tree. Small animals move through warm tunnels below the surface. Fish remain beneath the floating ice of a lake. Water waits inside mountain snow for another season. Frost grows slowly along a cold window. The entire winter world continues without haste. You can become quieter within it. Your hands can remain still and comfortably warm. Your shoulders can release the last small effort of the day. Breathing can happen gently in the background. Every sound may become softer and more distant. Every thought may settle like one final flake. The sky is wide, the snow is deep, and the night is patient. Nothing is asking you to remain awake. For now, the winter landscape can hold the silence for you, and you may rest beneath its calm, pale, and endlessly gentle light. The snow has stopped for a while, leaving the sky clear and deeply blue. Cold air rests across the fields, undisturbed by wind or passing clouds. In this stillness, the newest snow begins changing beneath the stars. Its surface releases warmth toward the open sky. The uppermost crystals become colder than the air just above them. Invisible vapor settles onto their edges and grows into delicate frost by morning. Tiny feathers may cover the smooth white surface. They rise from the snow like a miniature forest made entirely of ice. Each crystal catches light from a different angle. Together, they create thousands of brief and quiet sparkles. A single breath of wind may bend or scatter them. Sunlight may soften them before the morning has fully begun. Their short existence makes them no less beautiful. Winter is filled with forms that appear gently and disappear without resistance. Let each thought do the same tonight. It may form clearly, shine for a moment, and fade into stillness. On calm nights, cold air often settles into low places. Because it is denser, it moves downhill along slopes and gathers in valleys. This slow movement is sometimes called cold air drainage. It happens quietly beneath forests, across meadows, and beside frozen streams. A valley floor may become colder than the hills above it. Frost grows thickly in the lower ground, while higher branches remain almost clear. Mist may gather where cold air meets moisture from a river. Tiny droplets float near the surface and soften the shapes of trees. Under moonlight, the mist appears pale and almost silver. It moves so slowly that the landscape seems suspended between cloud and snow. Where the droplets touch cold branches, they freeze into fine white coatings. Every twig becomes brighter and more visible. Reeds beside the water carry narrow lines of ice. Grasses bend beneath crystals lighter than powder. When dawn arrives, the valley may look completely transformed. Yet the change came from movements too small to hear. The air simply cooled, settled, and met the waiting moisture. A frozen river behaves differently from a frozen lake. Water continues flowing beneath the surface, even when ice covers quieter sections. In narrow channels, the current may remain open through much of winter. Steam-like mist rises where relatively warm water meets cold air. The vapor does not come from boiling water. It forms because the cold atmosphere cannot hold all the moisture above the river. Small droplets appear and drift along the banks, trees near the channel collect frost from this passing mist. Their lower branches may become white, while the upper canopy remains dark. Along the water's edge, thin shelves of ice grow outward. They form slowly where splashes and small waves reach colder surfaces. Each night adds another narrow layer. During warmer afternoons, some edges melt and become smooth. The river continues underneath, carrying mountain water toward distant places. Snow falling into the current disappears almost immediately. The crystal becomes liquid and joins the moving stream. Other flakes land upon the banks and remain until spring. Two flakes falling side by side can begin very different journeys. One may reach the sea within weeks. The other may rest in shaded snow for several months. Water follows the conditions it meets without choosing a destination. There is something restful in that effortless movement. You do not need to choose where every thought should go. Let the quiet current of sleep carry them onward. Far above the valley, high clouds contain thin plates of ice. These crystals are often too small to fall as ordinary snow. They drift at great heights, carried by cold upper winds. When moonlight passes through them, it can create a wide, pale halo. The ring forms because light bends through many crystals at similar angles. From below, it appears centered perfectly around the moon. The clouds may be almost invisible except for this gentle circle. Sometimes two brighter areas appear beside the moon. They are created by flat crystals turning slowly as they fall. During daylight, similar lights can appear near the sun. Winter skies contain many quiet patterns made by ice and light. Arcs may curve above the horizon. Pillars may rise from distant lamps. Soft rings may surround the moon for hours. None of these lights are objects hanging in the sky. They are paths created as light passes through countless crystals. The effect depends on shape, angle, and the calm movement of air. A tiny crystal high above can redirect light towards someone watching below. Millions of crystals together create a pattern large enough to cross the sky. Small structures often create wide and beautiful effects. Snowfields create their own optical changes near the ground. On bright days, reflected sunlight reaches the eyes from many directions. Fresh snow can return most of the visible light that falls upon it. This makes a clear winter landscape feel intensely bright. Shadows remain blue because they receive scattered light from the sky. Sunlit areas glow with warmer and fuller colors. The contrast can make every ridge and footprint appear sharply defined. Animals living in snowy places have adapted to this brightness. Some birds and mammals have dark skin or markings around their eyes. These darker areas may reduce some reflected glare. Human travelers protect their eyes with shaded lenses or narrow coverings. Long ago, Arctic peoples created snow goggles with thin viewing slits. The small openings reduced the amount of light entering the eyes. Simple materials provided protection within a brilliant white landscape. Brightness can be beautiful, yet winter life also requires gentleness and shelter. At night, the same reflective snow has a much softer effect. Moonlight spreads across the surface and reduces the depth of darkness. A path may remain visible without any lamp. Trees cast faint shadows that stretch across the field. The snow seems to hold light close to the ground. Above it, the stars appear especially clear in dry winter air. Cold air often contains less moisture than warm air. With fewer droplets and less haze, distant stars can look sharper. Their light may flicker as it passes through moving layers of atmosphere. Closer to the horizon, the flickering often becomes stronger. different colors, separate briefly before joining again. A star may appear blue, white, red, and gold within a few seconds. The snow below does not create this movement. It simply gives the night a brighter and quieter foundation. Imagine lying safely inside while those stars shine above a white field. The window is cool, but the room remains warm. The sky feels distant, calm, and open. Nothing in that darkness needs your attention. Winter constellations move slowly across the night. Their positions change as Earth turns beneath them. Snow-covered forests rotate silently with the rest of the planet. Frozen lakes, mountain ridges, and sleeping towns share the same motion. The movement is constant, yet no one feels it directly. Stillness can exist within motion. Your heart continues beating while the rest of your body becomes peaceful. Breath enters and leaves while your thoughts grow quieter. Sleep approaches through many small changes rather than one sudden moment. In snowy forests, darkness changes the behavior of many animals. Some birds settle into sheltered branches before the temperature falls. They choose dense evergreens that reduce wind and hold pockets of calmer air. Their feathers rise slightly, creating a thicker insulating layer. Small bird may appear rounder during cold weather. This shape reduces exposed surface and traps warmth near the body. Its feet grip the branch while special tendons help maintain the hold. Even during sleep, the bird remains securely perched. Some species gather together inside tree cavities. Shared warmth makes the small space more comfortable. Others rest alone in cracks, nests, or thick vegetation as night deepens. Their body temperatures may fall slightly. This controlled change reduces the energy needed until morning. The bird's breathing becomes slower, and its movements almost disappear. Snow gathers outside, while warmth remains beneath its feathers. Woodpeckers often sleep inside cavities carved into tree trunks. The surrounding wood blocks much of the winter wind. Old nesting holes may become valuable shelters for many other species. Squirrels, owls, and smaller birds use natural hollows in similar ways. A tree can provide shelter long after a branch has stopped growing. Even fallen logs create protected spaces near the ground. Snow settles above them and closes gaps against the wind. Beneath the log, insects and small animals remain hidden. Fungi continue growing slowly through damp wood. The fallen tree becomes part of the sheltering forest floor. Winter does not stop decomposition completely. It only reduces the speed of many biological processes. During mild periods, microbes become slightly more active. When deeper cold returns, their activity slows again. This pattern continues beneath the insulating snow. Nutrients remain within leaves, wood, soil, and living organisms. Spring growth will use materials prepared during these quiet months. The forest future is partly built during its season of rest. Some animals enter much deeper states of winter inactivity. True hibernators lower their metabolism far below normal levels. Their body temperatures may approach the temperature of their shelter. Heartbeats become slow and widely separated. Breathing can pause for surprisingly long intervals. Stored fat supplies the small amount of energy still required. The animal is not simply sleeping through an ordinary night. Its entire body has entered a carefully controlled seasonal state. Ground squirrels are among the deepest hibernators. They shelter in underground chambers protected by soil and snow. Every few weeks, some briefly return to a warmer body temperature. Scientists continue studying why these short awakenings occur. The pattern may help maintain important body functions during the long winter. Bats also spend winter in places with stable temperatures. Caves, mines, and shelter structures protect them from sudden weather changes. They hang quietly with wings folded around their bodies. Disturbance can use valuable energy they cannot easily replace. Deep winter rest depends upon long periods of safety and stillness. Other animals use lighter forms of energy. Conservation. A chickadee may enter nightly torpor and warm again after sunrise. A hummingbird in a cold region can also reduce its metabolism overnight. The strategy lasts hours rather than months. It allows a small body to survive until food becomes available again. Winter rest exists in many degrees. Some creatures slow for one night. Others wait beneath snow for an entire season. All follow rhythms shaped by temperature, food, light, and body size. Rest is not identical for every living thing, yet every form serves the same gentle purpose. Energy is protected until the world becomes more favorable. Let your own body protect its energy now. The day has ended, and no more effort is required. Beneath frozen lakes, aquatic animals also reduce their activity. Cold water slows many chemical reactions within their bodies. Fish move less often and use less energy. Some gather in deeper areas where temperatures remain more stable. Others shelter near submerged plants, rocks, or fallen branches. The water just beneath the ice may be close to freezing. Deeper water often remains several degrees warmer. This difference is small, but it matters to winter life. Ice floating at the surface creates the protection below. Its open molecular structure makes it lighter than liquid water. The same structure also shapes the branches of every snowflake. A six-sided crystal in a cloud and a floating lake surface share one origin. Both come from the unusual way water molecules join when freezing. Beneath clear lake ice, trapped bubbles form pale patterns. Some bubbles come from air released as water becomes solid. Others contain gases produced within sediment and decaying plants. When rising bubbles meet growing ice, they become trapped in layers. Later bubbles stop beneath the first, creating stacks of white circles. The result can resemble frozen beads suspended in clear glass. Snowfall may eventually cover these patterns from view. The lake becomes white and featureless from above. The bubbles remain beneath, waiting for spring warmth. When the ice melts, their gases return to air or water. Nothing remains sealed forever. Cracks also form as lake ice responds to temperature. During sudden cold, the surface contracts. Long lines may open and travel across the lake. During warmer periods, the ice expands and presses against the shore. These movements can produce deep humming or singing sounds. The tones travel far because the ice acts like a broad, vibrating sheet. Lower notes may seem to come from beneath the entire landscape. Although unfamiliar, they are natural signs of changing temperature. Snow on the surface often softens these vibrations. A thick covering turns strong tones into distant murmurs. From a warm house beside the shore, the lake may seem almost silent. Only an occasional sound travels through the winter night. Then stillness returns across the white surface. On mountain lakes, surrounding peaks reflect sound and light. Moonlit slopes rise above the frozen water. Dark forests form narrow bands along the lower valleys. Snow slides gently from heavily covered branches. A small cloud may drift across the face of the moon. For several minutes, the lake becomes darker. When the light returns, the same landscape appears newly revealed. Nothing is changed except the direction and strength of light. Winter scenes often transform through very small differences. A cloud moves, a crystal turns, or a branch releases its snow. The landscape seems new without becoming unfamiliar. At high elevations, cold air, and low-pressure shape snowfall differently. Clouds may form where moist air rises along mountain slopes. As the air climbs, it expands and cools. Water vapor gathers into droplets and crystals. The windward side of the mountain receives much of this moisture. Beyond the ridge, the descending air becomes drier. One valley may hold deep snow while another remains almost bare. Mountain ranges guide storms across entire regions. Their shape influences forests, rivers, farms, and local climates. Snow stored on high slopes later feeds communities far below. Quiet cloud brushing a mountain can become water for millions of lives. The process begins with air moving upward by only a few kilometers. At the summit, wind may prevent snow from settling. Crystals race across exposed ridges and gather behind sheltered rocks. The repeated movement rounds their edges. Firm drifts grow in protected bowls and mountain hollows. In calmer forests below, snow remains softer and more open. The same storm produces many textures across the slope. Mountain animals learn these differences through long experience. Ibex and mountain goats choose routes where snow remains shallow. Their strong hooves grip rock exposed by wind. Ptarmigans walk across softer areas on feather-covered feet. Small mammals tunnel beneath deeper drifts near vegetation. Every creature uses the snow according to its own body and needs. Plants also depend on where snow gathers. A deep drift may delay spring growth, but protect roots from severe cold. A wind-cleared ridge receives sunlight sooner, but faces harsher temperatures. Some alpine plants survive only within particular patterns of snow cover. They grow where winter protection and summer warmth remain carefully balanced. A difference of a few meters can change an entire plant community. Snow creates invisible borders that return year after year. In spring, these borders become visible through melting patterns. Dark ridges appear first. Then small islands of grass emerge around rocks. Larger patches join as meltwater flows downhill. Flowers bloom along the retreating edges. The last snow remains in shaded hollows and beneath steep cliffs. Its water continues feeding the slope after surrounding soil becomes dry. A patch of winter can support summer life long after the storm is forgotten. Across polar regions, seasonal snow covers frozen ground called permafrost. Only the uppermost soil may thaw during a brief summer. The deeper layers remain frozen for years or much longer. Snow influences how much winter cold reaches the ground. A thick early covering can insulate the soil from severe air temperatures. A thinner covering allows deeper cooling. The timing of snowfall, therefore, affects roots, microbes, and stored ice. During summer, shallow ponds may form above frozen ground. Water cannot easily drain through the hard layer below. Birds, insects, and plants use these temporary wetlands. When winter returns, the ponds freeze beneath new snow. The cycle begins again across the tundra. Low shrubs bend beneath the snow and remain protected from wind. Lichens and mosses wade close to the frozen soil. Caribou later uncover them with broad hooves. Arctic foxes travel across the surface, listening for movement below. Snowy owls watch open ground from low ridges. Life remains sparse compared with warmer forests. Yet every organism is closely adapted to cold, light, and seasonal snow. During the polar night, darkness can last for weeks or months. The sun remains below the horizon, though faint twilight may still appear. Moonlight and aurora brighten the snow from time to time. Stars circle slowly above the white landscape. Animals rely on scent, hearing, memory, and subtle light. The snow reflects whatever brightness the sky provides. Even a distant glow can spread across the open ground. In summer, the same regions receive sunlight for nearly the entire day. Snow melts rapidly where the surface becomes dark or dusty. Ponds appear, streams widen, and plants grow quickly. The contrast between seasons is extraordinary, yet the transition happens through many ordinary days. Light returns a little longer, air warms slightly, snow grains become rounder, water begins moving beneath the surface. No single moment changes the whole landscape. Nature often transforms through accumulation rather than sudden change. Sleep can arrive in much the same way. Your thoughts become less connected. Sounds seem farther away. The body grows heavier against the bed. Breathing continues without conscious attention. One quiet change follows another. There is no need to notice the exact moment. Wakefulness fades. Beyond the window, the stars continue above the snow. Frost grows slowly along the lower edge of the glass. A few crystals still drift from the thinnest clouds. They descend through moonlight and settle upon the field. Their six-sided structures join a surface already filled with countless shapes. By morning, most individual forms will have changed. Some will be buried. Some will become rounded. Some will return directly to the air. Their brief patterns have already completed their purpose. They carried water, reflected light, and softened the winter world. Now they can rest among the other crystals. You may rest just as naturally. Nothing important requires your attention during these quiet hours. The lakes remain protected beneath floating ice. Animals remain sheltered beneath feathers, fur, soil, and snow. Mountains hold water for seasons yet to come. Clouds travel slowly toward another distant valley. The winter night continues its gentle work without any help from you. Let your muscles become loose and comfortably heavy. Let the silence between words become wider. The snowfield is calm beneath the stars. The forest is still beneath its white branches, and you are safe, warm, and free to drift more deeply into rest. A pale winter dawn begins forming beyond the darkened horizon. The snow remains blue beneath the last quiet hours of night. Before sunlight arrives, the landscape belongs to shadow, frost, and patient stillness. Every hollow holds cold air, and every branch carries a soft white line. The world seems motionless, although countless small changes continue beneath the surface. Snow crystals shift slowly as temperature moves through the upper layers. Water vapor travels from warmer grains toward colder ones. Some crystals lose their sharp edges, while others quietly become larger. The snow settles by fractions too small for the eye to notice. By morning, the surface may sit slightly lower than it did before. No melting was required for this gentle change. The grains simply moved closer as their delicate branches softened. Fresh snow begins as a loose gathering of ice and air. With time, it becomes a denser memory of the storm. Each passing hour reshapes the spaces between the crystals. Those spaces help determine how sound moves across a winter landscape. Loose powder contains countless openings that scatter incoming sound waves. Sharp noises become softer as their energy enters the snow. The effect is strongest after a calm and generous snowfall. Familiar places can suddenly feel wider, quieter, and farther away. A nearby road may seem distant beneath the white covering. Footsteps become rounded and gentle instead of crisp and echoing. Even voices appear softer when the ground no longer reflects them strongly. This is one reason snow can make a town feel deeply peaceful. The buildings remain the same, but the sound around them has changed. Let the silence between these words feel wider now. Your breathing can become quieter without any effort. As snow grows older, Its sound-absorbing structure slowly changes. Grains become rounder, and the air spaces between them become smaller. Meltwater may freeze into firmer bridges connecting neighboring crystals. The surface begins reflecting more sound than fresh powder does. An icy morning can therefore feel clearer and more resonant. A distant branch may crack and carry its sound across the field. Hard snow may produce a bright crunch beneath careful footsteps. Very cold snow can squeak when crystals break and rub together. The sound often becomes sharper as temperatures fall. In warmer conditions, a thin film of water softens the contact between grains. The same path may sound completely different from one winter day to another. Snow tells its temperature through touch, light, and sound. Animals notice these differences, even without measuring them. A fox, crossing firm snow, uses less energy than one moving through deep powder. A hare depends upon broad feet when the surface cannot support its weight. Birds search along crusted areas where seeds are easier to uncover. Deer follow packed trails created by repeated movement. Every winter's surface offers a different balance between effort and shelter. Some animals avoid open snow during the brightest part of the day. Their dark shapes become easier to see against the white ground. At dusk, long shadows provide more cover near forests and shrubs. The soft evening light also reduces the glare reflected from the snow. A red fox may appear copper-colored beneath the final sunlight. Its coat traps warmth through layers of dense fur. Its bushy tail can cover its nose while resting. Warm air remains close to the face beneath this natural blanket. Arctic foxes curl even more tightly during severe northern weather. Their compact bodies reduce the amount of heat lost to the air. Small ears expose less surface than the larger ears of desert foxes. Thick fur surrounds their paws and protects them from frozen ground. Their bodies reflect the quiet logic of the climate around them. Snowy owls use another set of winter adaptations. Feathers cover much of their legs and feet. Their pale coloring blends with open tundra and wind-shaped snow. They can remain still for long periods while watching the ground. Even beneath snow, small movements may create faint sounds. The owl listens to the cold air and shifting wind. Its flight remains unusually quiet because of specialized feather edges. Air passes across the wings in smaller, softer currents. The bird can approach without covering the sounds it needs to hear. Afterward, only a broad wing mark may remain in the snow. The shape fades as light wind moves across the surface. Snow records a moment without keeping it forever. Rest can work in the same gentle way. The mind may hold an impression briefly, then release it into quiet. Beneath the snow, many plants remain close to living temperatures. The air outside may fall far below freezing, yet the ground beneath a deep layer can remain near 0 degrees Celsius. This difference protects roots from the most severe cold. Low shrubs bend beneath the snow and escape drying winter winds. Some evergreen leaves continue small amounts of activity during milder periods. Mosses remain moist beneath the insulated surface. Tiny organisms move through thin films of unfrozen water around soil particles. Even frozen ground may contain microscopic pockets where life continues slowly. Water does not always freeze at exactly the same moment everywhere. Dissolved minerals and organic substances can lower its freezing point. Narrow spaces within soil also change how ice forms. These protected films support chemical processes throughout winter. The landscape above looks asleep, but the ground remains quietly responsive. Snow cover can also prevent repeated freezing and thawing near the roots. Without insulation, exposed soil may warm during the day and freeze again overnight. This movement can lift small plants and disturb shallow roots. A steady layer of snow reduces these sudden changes. The cold becomes more stable and therefore less damaging. Winter protection sometimes comes not from warmth, but from consistency. Let your body settle into a similar steadiness now. The bed remains beneath you, calm and unmoving. There is nowhere else you need to be. In open country, fences create long and graceful snowdrifts. Wind slows as it passes through rails, posts, and narrow gaps. Carried grains lose momentum and settle on the sheltered side. The drift grows outward through many hours of repeated movement. Its surface becomes smooth, although it is built from countless small impacts. A single fence can shape snow across an entire field. Trees create similar patterns around trunks and low branches. A shallow hollow may form where the trunk blocks falling flakes. Farther away, snow gathers where the disturbed air becomes calm again. These shapes can reveal wind direction long after the storm has passed. Snow preserves the invisible architecture of moving air. Around houses, the same process forms curved banks near walls and doorways. Warm surfaces may melt the nearest layer. Water then flows into colder snow and freezes again. This can create clear grains beneath the softer outer covering. Icicles begin where meltwater reaches an edge exposed to cold air. Each drop leaves behind a small amount of ice. The icicle lengthens downward through repeated freezing. Air bubbles and tiny impurities create pale lines within it. Sunlight later travels through the ice and bends slightly. A clear icicle can hold faint shades of blue, gold, and white. When the temperature rises, a drop forms at its narrow tip. It hangs there briefly, reflecting an upside-down winter scene. Then it falls and joins the snow below. At night, colder air may begin the process again. Winter shapes grow through repetition rather than haste. One small drop follows another. One quiet hour follows the next. You may let sleep approach through the same patient rhythm. No single breath must carry you there. Each one can simply soften the moment that came before it. High in the atmosphere, snow begins wherever ice can grow inside clouds. Not every cold cloud produces snowfall. Some lack enough moisture, while others contain crystals too small to descend. A crystal must grow heavy enough to overcome the rising air around it. Even then, wind can delay its journey toward the ground. Strong upward currents may return it to higher and colder levels. There, it can gather more vapor or collect supercooled droplets. Its path may circle inside the cloud many times. Eventually, gravity draws it into quieter air below. Some crystals evaporate before reaching the surface. This creates faint streaks hanging beneath distant clouds. The falling snow is visible, but it disappears into dry air below. Meteorologists call these trailing streaks virga. From far away, they look like pale curtains beneath the cloud. No flakes reach the ground, yet moisture has still traveled downward. The crystals return to vapor and remain within the atmosphere. Another cloud may use that same water later. Snowfall is therefore not always completed in one journey. Sometimes the sky begins and then quietly takes the crystals back. In colder air, flakes survive their entire descent. They may pass through dry layers and become smaller. They may enter moist layers and grow larger through aggregation. Near freezing temperatures, the crystals become slightly sticky. Several flakes can join into broad clusters. These are the large, slow flakes often seen during peaceful winter storms. Their shapes are less perfect than individual crystals, yet their movement can appear especially soft and dreamlike. They turn slowly because air pushes against their wide, irregular surfaces. A gentle wind sends them sideways across a window. Some cling to the glass for a moment before melting. Their branches collapse into clear drops. The water flows downward and joins other drops along the pane. Outside remains frozen, while the inner surface stays warmed by the room. The window becomes a narrow meeting place between two seasons. On one side, snow continues falling. On the other, warm air holds invisible moisture from breath and daily life. Condensation may form where the glass becomes cool. Near the edges, the droplets can freeze into thin frost. The frost begins at tiny scratches, dust particles, and uneven places. Ice spreads outward in branching patterns. Some designs resemble leaves, feathers, or distant rivers. Their appearance is guided by temperature and available vapor. As the room warms after sunrise, the patterns slowly retreat. The crystals become droplets, and the glass clears again. A complete cycle may happen within a single night. Water moves from vapor to ice, then back to liquid. The changes are ordinary, but their forms remain beautiful. Across frozen wetlands, reeds rise through snow and thin ice. Their dry stems remain from the growing season before. Wind moves them gently, creating small circles in the surrounding snow. Hollow stems can carry gases between mud and air. Beneath the surface, roots and microorganisms remain active at reduced rates. Methane and other gases may rise from decaying plant material. When bubbles meet freezing water, they can become trapped, layer after layer. Circular forms appear within the ice. Snow later hides these patterns from the sky. Below, they remain like pale beads suspended in glass. In spring, melting releases the bubbles into water and air. The wetland returns to movement, sound, and growing green leaves. But through winter, it rests beneath a quieter design. Frozen marshes provide shelter for many animals. Muskrats use lodges and underwater entrances during the cold months. Beavers keep stored branches near their homes. Otters travel between openings in rivers and lakes. Their dense fur protects the skin by holding warm air close. Unlike many marine mammals, otters depend more on fur than thick body fat. They groom carefully to maintain the insulating air layer. After entering water, they return to snow-covered banks. Dark, wet fur may briefly mark the surface. Then they shake, roll, and move toward another sheltered place. Their path curves playfully along the river edge. Snow can make movement easier for some creatures and harder for others. A smooth slope allows otters to slide. Deep powder slows deer and other heavy animals. Firm crust supports small bodies but breaks beneath larger ones. The same surface offers many different experiences. Snow has no single meaning within an ecosystem. It is shelter, obstacle, water, camouflage, brightness, and stored energy. Its value depends upon the creature, season, and depth. For a dormant seed, snow is protection. For a hunting owl, it is a surface carrying faint sounds. For a river, it is water waiting for warmth. For a glacier, it is the beginning of another layer. For a sleeping person, it may simply be a peaceful image. Let that peaceful image remain with you now. A wide field lies beneath the last stars. No tracks cross the center. The surface rises and falls in barely visible waves. A line of trees stands along the far boundary. Their branches are dark beneath narrow caps of snow. A frozen pond rests between the field and the forest. Its edges are hidden, so land and water appear continuous. Only a few reeds reveal where the shoreline begins. Somewhere beneath the ice, water remains liquid. Fish move slowly through the colder season. Their muscles work more gently in low temperatures. They need less food because their metabolism has slowed. They choose deeper places where conditions remain stable. Above them, snow limits the light entering the lake. The underwater world becomes dim and blue. Plants reduce their activity and growth nearly stops. Yet the lake continues holding oxygen, nutrients, and life. In early spring, sunlight begins passing more strongly through thinning snow. Microscopic algae can respond before the ice disappears. Small changes in light begin waking the lake. The season turns first through signals too subtle to see from shore. The same is true across forests and mountains. Day length begins increasing long before snow melts. Animals sense the changing light through their eyes and nervous systems. Hormones adjust, feathers change, and migration timing begins. Trees remain bare, but their buds are already prepared. The next season exists quietly inside the present one. Winter contains the beginnings of spring. Sleep also contains the beginnings of morning. Yet morning does not need to concern you now. It will arrive on its own. For these hours, darkness is useful and complete. The world outside can continue without observation. Clouds can form over distant water. Snow can gather across mountains. Animals can breathe beneath fur and feathers. Ice can grow across the edges of lakes. Frost can spread along windows and silent grass. Nothing needs to be watched or managed. The natural world follows patterns older than memory. Water rises, cools, freezes, falls, and moves again. Snow becomes stream, lake, ocean, vapor, and cloud. Each form is held only for a while. The quiet science of snow is partly the science of change. Solid forms appear within moving air. Delicate crystals become broad snowfields. Soft layers become glacier ice. Frozen water becomes rivers beneath a warmer sun. Nothing rushes, yet nothing remains completely still. Allow your own thoughts to become part of that gentle movement. They do not need to stop before sleep can come. They may drift, soften, and lose their edges. One may join another, then disappear into the distance. The mind can become quieter without becoming empty. Breathing continues beneath everything. The body maintains warmth, circulation, and calm internal rhythms. Your heart performs its steady work without needing instruction. Muscles release small areas of tension, one by one. The face becomes softer around the eyes and jaw. The hands rest without holding anything. The legs become heavy and comfortably still. Outside, the first hint of dawn touches the eastern snow. The color changes from blue to pale silver. High clouds receive a faint shade of rose. The lowest valley remains in darkness a little longer. Light reaches the highest branches before the forest floor. Frost crystals brighten one after another. For a moment, each tiny edge carries the morning. Then sunlight spreads across the entire field. The night's patterns will slowly change beneath its warmth. Some frost will vanish directly into the air. Some snow will melt into clear droplets. Other places will remain frozen throughout the day. Every surface responds according to shade, depth, and temperature. There is no single moment when winter becomes morning. The change arrives softly across thousands of separate places. You do not need to wait for it. You may drift beyond these images before the light reaches the ground. The snow will remain peaceful whether you are listening or asleep. The frozen pond will hold its quiet water. The forest will shelter birds within its branches. The mountains will keep their stored winter snow. The clouds will continue across the open sky, and you can rest here, warm and protected, while the pale world slowly brightens. The pale morning light spreads slowly across the untouched snow. Every crystal receives the new brightness in its own brief way. Some surfaces flash clearly, while others remain blue within soft shadows. The landscape seems simple from a distance, yet every meter holds different conditions. Wind has polished one ridge and filled another with loose powder. Sunlight reaches the open field before entering the sheltered forest. Near the trees, the snow remains colder and slightly deeper. Along the southern slope, warmth has already begun changing the uppermost grains. A thin layer softens, then freezes again when evening returns. Through repeated warming and cooling, the snow develops new textures. Soft powder becomes rounded grains. Crust, ice, and eventually flowing water. The water itself remains unchanged, though its arrangement is always shifting. This is one of winter's quietest lessons. A familiar substance can take many forms without losing its essential nature. You may let your breathing remain gentle while the morning grows brighter. There is no need to follow every change across the snow. In the deepest mountain valleys, sunlight may not arrive until late morning. Cold air remains pooled beneath steep slopes and dark evergreen forests. Frost holds its delicate shape upon stones, branches, and sleeping grasses. Where the sun finally touches, the smallest crystals begin disappearing. Some melt into droplets too small to see. Others change directly into vapor and return to the air. This direct movement from ice to vapor can happen during cold, dry weather. A snowbank may slowly shrink without producing visible streams. Sunlight gives molecules enough energy to leave the crystal surface. Dry wind carries them away into the atmosphere. The snow appears solid, yet its edges are always exchanging water with the air. At night, the opposite exchange may return vapor to the ground. New frost grows upon old snow under clear and quiet skies. Water moves in both directions through an invisible winter conversation. The surface breathes moisture into the air, then receives it again. Across open plateaus, blowing snow can continue after clouds have disappeared. Loose crystals lift from the ground and travel close to the surface. They bounce, slide, and briefly rise within the moving air. This low movement is called drifting snow. It creates narrow streams of white that pass across roads and frozen fields. Farther above the ground, stronger wind can carry crystals into pale moving veils. The sky may remain blue while snow travels horizontally beneath it. Each grain becomes part of the atmosphere again for a little while. When the wind weakens, the crystals return to sheltered hollows. They gather behind ridges, trees, walls, and stones. A smooth drift grows through many small journeys. Its final curve reveals the shape of air flowing around the landscape. Wind is invisible, but snow gives its movement a visible form. Even a gentle breeze leaves a record across the winter ground. The lines may remain for hours, then soften beneath new snowfall. Nothing written upon snow is meant to last forever. Let that thought feel peaceful rather than sad. The world can release its patterns and create them again. In forests, sunlight reaches the ground through changing spaces between branches. Bare deciduous trees allow more winter light to enter. Evergreen canopies create deep green shadows above the snow. Falling light reflects upward, illuminating the lower sides of branches. A forest in snow is bright from directions that summer rarely provides. The ground itself becomes a broad and quiet source of reflected light. This brightness helps reveal tiny movements near the surface. A seed falls from a cone and leaves a small mark. A bird lands briefly, pressing 3 narrow toes into the powder. A squirrel crosses between trunks and disappears above the branches. Its tail brushes the snow and creates a faint sweeping line. Later, loose crystals slide inward and soften each impression. By evening, the tracks may become only shallow shadows. At night, new snow may cover them completely. The forest begins again with a smooth, white floor. Animals do not experience this covering as an empty surface. They read scents, textures, hardness, and hidden movement. A fox can smell where another animal crossed hours earlier. Deer recognize packed trails beneath the new dusting of snow. Small birds search near trees where wind has exposed fallen seeds. Ravens investigate dark objects that contrast with the pale ground. Each creature notices a different part of the same landscape. Snow becomes information as well as shelter and stored water. It reveals movement while hiding colors and familiar shapes. It can make distant objects visible and nearby objects disappear. A white hair resting beneath a snowy branch may remain almost unseen. A dark bird flying above a field becomes clear from far away. Winter camouflage depends on light, season, and the changing depth of snow. Some animals gradually replace darker summer coats with pale winter fur. The change is often guided by day length rather than snowfall itself. Shorter days influence hormones that begin the seasonal transformation. If snow arrives late, a pale animal may stand against dark ground. If melting comes early, the same contrast can appear in spring. The body follows a rhythm shaped by generations of seasonal change. Snowfall and daylight usually move together, though not always perfectly. Nature contains careful patterns, but also uncertainty. Animals respond through movement, shelter, memory, and adaptability. Their winter lives continue through many small decisions. A hare chooses a protected resting place beneath a shrub. A bird searches one more branch before entering its nighttime shelter. A fox follows a quieter path along the edge of the trees. A mouse returns through tunnels beneath the insulating snow. From above, the field remains calm and almost featureless. Beneath it, many lives are moving carefully through winter. Take a slow breath and imagine that protected world below. The snow above holds back wind and softens every distant sound. Snow can also preserve scents for animals with sensitive noses. Cold temperatures slow the movement and break down many chemical traces. A track may carry information long after its maker has passed. Warm air rising from beneath the snow can bring faint scents upward. Predators. Listen and smell for small animals moving below. Prey animals detect visitors approaching across the surface. The quiet landscape contains signals beyond human hearing and smell. Winter stillness is rich with information for creatures adapted to notice it. Humans often experience snow mainly through sight and sound. We see softened edges and hear the reduced echoes. Animals experience temperature, pressure, scent, and vibration more directly. A hoof senses whether a crust will support its weight. A paw feels the difference between dry powder and hidden ice. A bird notices wind direction through feathers along its body. Each movement becomes a small conversation with the snow. In northern villages, people also learn to recognize many winter surfaces. Fresh powder behaves differently from wind-packed snow. Old crust carries weight differently from newly frozen slush. Snow near rivers may hide warmer ground or moving water. Snow beneath trees